Hey! Welcome to Automat Live Coding. This is the stream where we write Automat, this tool. It's a utility that can automatically perform actions on the desktop, such as moving the mouse or clicking various keys. It works by giving you access to a wide range of objects that you can then connect together, and they can do stuff. Here is a macro recorder that I used to record the macro. We've been working on this for, I guess, like 2 weeks now. When I play it back, I can lift my hands and my mouse will move according to the trace that I recorded earlier. That trace, if I pause it and zoom in at any point, you will see that actually it's composed of a lot of very fine events. So each of those events, I can move it like that, is a movement by just a couple of pixels. This is how mouse signals, how the operating system signals the movement of the mouse to various applications. So in Automat we can intercept this, record this into a timeline, and if we connect this timeline into a mouse movement object, it's going to move the mouse for us. So we have those mouse traces. Today, the plan for today's stream is to address some of the bugs that exist here right now. Whenever we add a new big feature like this one, we always introduce some issues. That was the case right now as well. So if I, for example, start recording a macro from the middle of the mouse trace, it's going to corrupt the data, and the corrupted data is still going to work, but not that great. So we're going to fix this. We are going to address some behind the scenes code quality issues. So in Automat, each of those objects that you can see on screen is actually composed of two elements. There is an object, which is purely, let's say, purely logical construct that can perform the action, and there is a widget. The widget is the stuff responsible for display. So objects, even if you close the window, if you have totally invisible Automat, the objects still work, so they can perform actions even when the window is closed. The split is there because we want to save resources. Like when we don't have a window, we don't want to waste memory or CPU time to render those objects. So this split is very necessary. There are many objects in Automat which are still combined. The object is the widget. It wastes a lot of memory. We want to avoid it. So we will do this. And then there is a small issue about timeline splicing. So right now I have this, I can actually zoom in to some section of the timeline. For example, I will position the pointer, let's say here, on this loop here. So the thing is, I can fold, you can see this. This is the mouse movement. I can fold this whole section of mouse movement, sorry, this one, for example, up till this point, by using this button. But I don't really see where it's going to end. I can do this, and you can see it actually did splice the mouse trace. However, it combined a big section of movement into a single large movement. It's not exactly what I want. I can do more of those. Cut one more splice. Yeah. So this is a useful utility because it allows you to make the mouse movement very fast. It's often very valuable when you're recording macro and you want this macro to be executed faster than you actually did it yourself. Oh, a crash. That's nice. But I think this crash might have been related to splicing. So we will try to fix this splicing as well. The splicing is a tricky issue, but I will explain more later on. Okay. Before we start, a couple of announcements. So I was working on some other things, like the article for the Live 2025 conference. So I didn't have much time outside of streams to work on Automat. I mean, I was working on Automat, but I was working on different things. So I paused the vlogs, but now that I have more time again, we will be able to resume them. I actually wanted to record a devlog right now, but for devlogs, I actually want to have a slightly better, say, plan of what I want to deliver. There are definitely things that happened since the last devlog. If I check the YouTube page and look at videos, yeah, the last devlog was about conditional instructions about still parts of assembly. So many things have happened since then. So we have a new menu system. Sorry, we have a new bubble menu. We have mouse traces, and probably some more things, some more smaller behind the scenes things that still could be published as devlogs. So we will do this maybe next week, maybe on Monday. Monday is a good day to record the devlog. Then watching together. So last week I've done some watching together on stream and it was fun. I think I will do more of this. It's very valuable to me as a break because coding for a longer period, like in a row, it can be exhausting, like, but in a very weird way, in a similar way that you get kind of tired after you have a lot of exercise. Just breaks generally help. So this is something for me that's going to help me kind of attain higher kind of focus for longer periods of time. Like, but also it's a nice way because it allows me to catch up with some of the materials that I want to watch or understand. And the last one is I have a vacation coming up starting in August. So I will be streaming for the next week and then I will take a longish break, 1.5 months. So the next stream will be this on Monday, 15th of August. So those are the announcements. Now, I wanted to, let's say, ramble for a little bit about Automat roadmap. I have some good news. So, menu design. Menu is something that is, for me, a very sensitive topic. It's something that is necessary in any design, like in any application, in any complex application, which is supposed to do many things. It's just impossible to show all of the options that you have available to you all the time. So the design of the objects in Automat, just so that they are readable, it just cannot expose everything. But hiding stuff is very bad for literally anybody who's using an interface. The design of objects should, it's called affordances. It should signal you visually the things that you can do with those things. So a timeline, when you look at it, you can see, oh, it has those 3 buttons. So those are 3 actions that I can kind of perform with it. It has this weird thing, and if you look at it, you will see that it has those this subtle gradient, this vertical gradient, and the point of this gradient is to signal to the user that, hey, you can touch it. It's meant to resemble a scroll bar, a physical device that you could use to scroll things. On a radio. I have a radio behind me. It has a very similar thingy. Same with this. It's meant to signal to the user that, hey, you can change the zoom smoothly. So we have all those things, and some of the things I keep in the menu. I mean, you will actually see that all of those things that are in the menu can be performed directly, but still the menu is there. So I can move the object by grabbing it, but I can move the object by invoking the move action from the menu. I can delete this object by dragging it to the delete zone. It's called, this delete zone is going to look differently soon. Or I can drop it out of the canvas, but I can also do it from here. And finally I can run it, and running it is no different from pressing the play button. So most objects, I don't actually remember. I think the only object which actually has some hidden options is this one right now. The assembler object has a hidden option to show registers. And this is because the number of registers that could be shown is just so high that it's just impossible. I mean, not right now, but eventually it's going to be so high that it's going to be impossible to show all of them. On ARM, for instance, you have a huge battery of registers, and yeah, that would make it totally impossible to use. I mean, I could make those buttons infinitely small, but there's one more thing. Automat is meant to be used at a fixed scale. So this zooming that I'm doing all the time, basically, when I'm using this, it's basically a debugging tool for me, because normally when you use it, you shouldn't care about zooming. It should be usable at the default zoom level. That's the plan. And because of that, we cannot scale buttons infinitely. We need to stuff them into the menu. And I dislike this because menu is context specific. So when you move your mouse, different elements, you never know the element that you are hovering. Like, is this going to invoke the menu for the play button, or maybe for the timeline, or maybe the global kind of bubble menu? So I'm not a big fan of context menus, because you don't know which element you will activate when you click. So the menu system needs to have some properties that will make this easier. And maybe on a PC where I have a mouse, this works, but I'm also thinking of mobile devices where we don't have mouse. We don't have any sort of hover feedback. It's really painful to me to... I need to somehow to properly design this so that it also works smoothly on mobile. But there was a major breakthrough yesterday. I finally figured out how to signal keyboard shortcuts in the menu. Keyboard shortcuts are amazing because, let's say you are hovering over this timeline and you want to run it, right? You can either press this button or you can open the menu and press the run option. But I would like to associate the run option with space. Running is something obvious, right? It should be under space, a convenient place. So I was thinking how to communicate this, and I think in Automat we will have a tiny keyboard in the corner of the screen, here or maybe in the center. Probably not in the center, it's better to stuff this in the corner. So we will have this tiny keyboard, and maybe the keyboard will be extendable. And as you are moving your mouse, the keyboard is going to show the representation of what will happen if you press a specific key on over a specific object. So if I have my mouse here, I will have a tiny keyboard here, and on space it will say run. And on, for example, the E key, it will say that, hey, if you press E, you will lift it up. So there will be a text or an icon saying that, hey, you will grab it if you press this key. We will have a lot of icons for each action. And they will be on top of a tiny keyboard here. So this will help with this hover behavior. And I really like this because not all devices have keyboards, right? There are many devices without keyboards. It's going to show you, without polluting the main interface, that hey, you can actually use those buttons to work faster. So it's a very good teaching mechanism, I think. Yeah. And we'll also have to figure out something with touch devices. On touch devices, this feedback is harder because buttons are fairly self-explanatory often, but the objects not so much. So I think on touch devices instead of moving the objects as a default action, we may have a selection action. Or maybe I can also have selection on desktop. So we'll have a completely new concept in the user interface that's going to change how it works. And the shortcuts on the bottom of the screen will form a row, not a keyboard. Yeah, and this toolbar is possibly going to be folded as well into menu. I mean, if the menu is actually a keyboard, then it might actually be pretty nice. Okay, so that was the menu system. I'm actually thinking of those bigger problems because when I'm on vacation, I intend to pick a problem, like one of those not less stream-friendly problems, and I will try to work on this offline. Many is one candidate. Okay, Another topic I wanted to mention is that we have some stuttering in Automat. This stuttering is very annoying. You cannot see it when I do this movement. Like when I do this, it's actually super smooth. If I point to, for example, this dot, you can see that when I move my mouse, it's not detaching from the point where I clicked it very much. So the frame rate is pretty decent. I don't know if you can see it, but I have screen tearing enabled, so the latency is actually lower here and slightly higher here, because I have a tear in the middle of the screen right now.
TiVo1960 says,
Is it easy to find freelance developer jobs given the high number of developers in the market?
That's an interesting question. I don't know. I haven't been doing freelance in a long time. Like, really long time. More than 10 years. 10 years ago it was fairly easy. Okay, stuttering. So, I was looking about how to fix this on... Like, it would be best if there was some Vulkan extension, and there is such an extension that we could use. It tells us how long a frame that we submitted has been waiting on the GPU before it was displayed, which is exactly what we need to minimize the latency. And it tells us if we missed a frame. So this is one option that we can use. Another option is to use DRM/KMS on Linux. So this is alternative to X11. So if we run it Automat like that, Automat is not going to be displayed on your regular screen, it's going to allocate a new screen. So when I press I don't know why it's not allowing me to move. Oh yeah. Yeah, it's going to show something like that. So this is a raw Linux terminal. From this point, here I could start Automat and it could display, it could take over the displays essentially. So now I could switch back to my main display, which is here, okay, it's here. And yeah, Automat could essentially display itself elsewhere and control X11, no, even on a different machine. Actually, this sounds like an amazing thing to do. This is something that I think would be pretty sweet. So X11 allows us to run applications on different machines and connect to different machines to automate them. So I think it should be possible to connect Automat over X11 to a different computer. Ah, I haven't thought of that. Let me quickly record this in the to-do list. The big benefit of this remote automation is that I think it's possible to have a separate PC that will run Automat and will control a game on another PC, so you can theoretically tweak the macro while it's executing. That would be super nice. super nice if we can make this work. But okay, when an application displays itself using this mode, then we have full control over the GPU. We get direct access to the textures which are displayed on screen, and we can even control hardware overlays, which is something that, yeah, there are just so many funny things inside the GPUs that you don't get access to if you're running as a regular application, but that we could mess with if we had a KMS, sorry, DRM client. Also, if Automat runs directly on the DRM, it should be possible to also host applications. So it just opens up so many possibilities. So this is a breakthrough capability. It opens. So remote connections are possible. Actually, no. Those other things are not really related. So I wanted to mention that it's possible to run Automat as a host. Like, it will be possible to run Automat as a host for other applications on Linux. This is a thing on Linux. On Linux, you don't really have top-level kind of mandated way of displaying things. Instead, you have two protocols. You have X11 and Wayland. And both of them can be implemented by anyone. And as long as they follow the protocol, any application can display itself in another application by following one of those protocols. That would be nice. So Automat will be desktop environment, kind of, if we can make this work. It's going to be tricky, but it's totally not impossible. Like, handling this protocol is absolutely doable. And it's also such a nice incremental thing, because implementing the basic protocol is something that can be done in a day, and then you can iterate over new features or new sub-protocols. Wayland has... Oh, there was this... has a bunch of... You can open the menu. So here in the sidebar you can see different protocols that Wayland supports. So the core protocol, the core Wayland, is just this. It's not that many. We have to implement basically all those objects and functions. And from that we can add more and more. Yeah. This will be super nice. Implementing DRM, this part is more work. This is harder than the interface, the Wayland or X11 interfaces. Here we have to follow very specific API that Linux exposes to applications. It's still doable. But you can see, the documentation is rather long. I mean, actually not that long, but this is just part of the documentation. Okay, so that was the other point I wanted to mention. If we do this, then we get access to a lot of tools, and we can also completely eliminate latency using those hardware overlays. It's a hardware feature that can allow us to display stuff very, very fast. and they are pretty much universal. For instance, the way that mouse is displayed. If you're using a computer and you're wondering why the mouse is often very, very fast, it's because mouse is using those hardware overlays. And I think my X11 server is probably using the hardware overlay for the front window, because when I move it, it stays attached to the mouse. It's very responsive. Yeah, so my guess is the X is actually using hardware overlays to position windows on screen. Okay, so with all of this out of the way, let's get on and let's start with the meat for today's stream, splitting the Vec2Track and Vec2Track widget. Failed to insert recording. Interesting, interesting. We have some error cases to cover. I was talking too much. When I talk too much, I sometimes lose my voice, so I feel I'm close to losing my voice. Half an hour of talking, that's a lot. Okay, we have this terribly divided file. I mean, it's a single file. It's not terrible. It's not terrible. I wouldn't call it terrible. It's just a massive file which contains a lot of things. It contains a lot of them because the interface between timeline and tracks is in flux. So I don't want to solidify this interface by splitting it into separate files. Not yet. But it probably makes sense to do some splitting now. I mean, not into separate files still, but objects. Let me open the header. So the first object that we will have to split is this one, track base. It's not going to be inheriting from fallback widget anymore. Let's define it here. A widget needs a pointer to its parent object, which is already covered in the fallback widget. And it's going to define a couple of methods, like those. And because we are defining them in line, I can just move the definition here. We need to split some things, so yeah. Actually, it's just a regular pointer. It should not be a regular pointer, probably. So we have some code paths here which are meant to be able to display a track which is separate from a timeline. it is something that I haven't finished. It just wouldn't display anything. I mean, it could display something. It would likely crash if I did that. If I extracted track out of a timeline. But the idea with those tracks is that they are objects themselves. They should be adjustable. So timestamps. We have to do that. Okay, then I can remove this shape from here. Okay, the next function is texture bounds, which I can also just move. I like to have them inline. So it says null pointer. I will have to think about how I'm handling this shape and texture bounds. Okay, then I have this. I can also inline. And finally, some derived objects. Like on-off track. Can I do this? Okay. So the default object has a function which casts itself into a widget and returns that, but I want each of the types that derive from it to return the appropriate subtype. Draw, there is this find action. Where is this find action? Here. I also want to inline it. This is actually nice because I can now fold all of this. It takes less space. The code is better organized if I define all of the functions in line. So, on-off track widget, yes, it's going to derive from this track-based widget. No, we are not going to have function like that. We will have this draw function. And we can get rid of this. So this subclass just defines a different drawing routine. Yes, I did override here. And I will do the same for vec2 track. Yes. And I'm going to move this massive implementation inside. Yes. Thank you. Okay, so this draw can be removed, but we need make widget. On of track and vec2 track. Now we have this. And I think we need to pass something into the distractor. Okay, so fallback widget doesn't have a distractor, but we need to set this object field. Okay, I will also address this. I will add the missing field into the constructor. It should be there. It just should be there. And the same I will do for on-off track. Cool. Some error here. We don't have timeline. Yeah, I see this is a recurring problem. Okay, I need some to-dos, so. First I want to fix most of the boring compilation issues. So
Terror uptone 1900.
okay, on at infer references if I know that the object is here. Suppose there will be more issues here. We need values, and that should solve most of the compilation issues. There are still quite a lot. Okay, track has no parent. Timeline probably has some visit children function. Yep. So this is going to force the rendering engine to render stuff. Actually, this is nicer. To render this stuff without stuttering. Let's continue. Okay, we actually are doing this in a lot of places. Maybe I could have a helper function. Continue, same problem. Continue again. Again. I will put this wake here, and now we should be able to get rid of this. Okay, if phase is set to animating, we are returning animating anyway, so I think we can do this. Just 3 more errors and it should compile. The fact that it compiles doesn't mean that it works. Is the problem? Okay, this is... We'll fix this. Oh yeah, because we have an array of smart pointers. Terrible stuff, terrible stuff. So when we are drawing the timeline, we need to pass this into draw children span. Should be a better way to display, to explain what I mean here. Instance of this class provides it's just about the behavior of the objects, not necessarily how they appear. It's even worse now. It's even worse than it was. There should be some visit children function here, I think. should visit all of them. That should have the same nasty piece of code. It's just a regular pointer, 8 bytes. So technically speaking, it's just a pointer. It's just a loop, right? Once this widget is being made, I should store this, I think, somewhere. So a timeline. It has this for tracks.
CP Chica says,
Hello.
Hey! It's marked as const.
Yesterday I was building on a needed run. Script 4 or 5 times if I recall correctly. Is that known or I just have weird setup of Windows?
Those are bugs. So usually when the build fails at some point, it's because it assumed some other process has. It's because of probably missing dependencies between build steps. At each step, when it complains, it should probably say which build step was failing, and that build step should basically say, hey, I couldn't finish because this was a problem, and it usually points at another build step which was executing probably in parallel.
For me, it failed when fetching dependicize.
Interesting. But it recovered? That was probably Skia. Skia has a lot of dependencies. Skia has has their own step which fetches up externals and populates the externals directory in Skia.
Illure, LVM Skia, Leptonica, then LVM again, and LVM again on G.
Yeah. It sounds like one of those issues. Skia and LLVM are the biggest sources of those problems because they take a long time to build, so any process which depends on them being there is likely to fail. And when you retry, it's possible that it will succeed because the LLVM build process probably progressed in the meantime. I was trying to make sure that this script runs well on GitHub workers, because GitHub workers have fairly clean setup. It's very reproducible, very stable, and it doesn't have all of the dependencies. So I was hoping that by making it run on GitHub workers, I will make sure it just runs everywhere in general. But I think I missed some things. So there's probably, for example, Windows SDK. Like that was one problematic thing that I added only recently. Yeah, it's just the build script has dependencies that I need to cover. I just need to get a fresh Windows install and try to install it there, and then each of those issues, they are all fixable by inserting those missing dependencies between build steps. You can actually see this if you run it, and if you manage to run the dashboard. This is the build graph, this is the Automat build graph. There is something here that depends on LLVM. If I find the LLVM, it's just the arrow is missing. There is also this problem with some compilation steps. There are some parallelism issues in run.py. I mean that when it builds Skia, it runs it and it tells to use all of cores to compile, and when it builds LLVM, it runs it and it tells LLVM to use all of the cores to build it. So it leads to a lot of contention on the CPU. It's all fixable. So the build jobs for Skia and LLVM should actually, say, take more slots when executing in parallel. That would also help with this issue. Because when we start LLVM compilation, we will not start anything that depends on LLVM being compiled in parallel. But that would just hide the issue. The true issue is lack of dependency relation. I'm glad it recovered after multiple attempts. It's... it can be weird to see an error which is different every time you run the process. So you run it once, it gives you one error. You run it second time, another error. I'm happy that it progressed and eventually resulted in working build. Okay, why is this usually here? I just changed the definition. Maybe first I have to fix this. Yes, let's do this. And okay, we'll just make it mutable. Yep. Few children. The same problem. I don't like to have this in two places, but it's a tiny piece of code. What? It's a regular pointer. How did this work then? Okay, it's acquire PTR. Ah, this is the agent doing its nefarious job inserting bugs in the system. Ew. One more compilation issue. Update child transform. And that should be it. I would be surprised if it works right out of the box. We should have some crashes. The standard thing. We'll try to pick a video, something that we can watch now. I think I had a playlist. Works. Wow. Okay, splitting those objects isn't that hard, apparently. So I've done this for track, maybe I should do this for timeline as well. Timeline is going to be more tricky. Oh yeah, it's not span is const. It's a span of const pointers. This is how it should be, but okay, it's not necessary now. A quick check whether this makes sense. I like that the header got smaller. It's always better. We have this new helper function. That's nice. And this I fixed. The two other I will try to fix in the subsequent commit. start with this. Let's figure out how to refer to timeline in a convenient way. Our widgets. They are somewhere here. So one rather important thing is to avoid duplicating the same information, because duplication leads to consistency issues. So we have a pointer to base object. I think the best way is a weak pointer, unfortunately. The best way to make it work is to there is a pattern, like a good way to do this, but it's quite a lot of code. Maybe it's not necessary, but whatever, let's just do this. So this is just a way to share code between many different sub-functions here. Context is maybe not the best name, but it's within track-based widget, so it should be clear what it is. We will prefix it with this name. So every track-based widget has a pointer to its track base. It has a pointer to the timeline. I think we need timeline pointer or whatever, let's just store it as regular pointer. Timeline. And for common things like distance to seconds, we will also store them here. Okay, now whenever we need something, we will not get it ourselves, we will ask timeline, this context, to give it to us. This is an ephemeral object. It should be deallocated when we exit the function. The advantage of this context is that we can theoretically pass it around and reuse the state we are kind of computing here. except we are not going to use this timeline directly. We will have let's just call this net timeline because we are confusing it. And the one thing that we should have here is this track PTR. It's also going to be done like that. Track PTR is actually a heavy object. It involves some sync operations, so we will pass reference to this. It's pointer to pointer. Okay, we can get const reference, that's fine. It doesn't matter. So now we don't need track timeline, distance to seconds. Let's put this comment here. It was a good comment. I wonder if this end time is used in other places. It feels like it could be. Timestamps is definitely used in a couple different places. No, this is not what I want. Yeah, just a static cast like this one. Now, my hope with this context is actually that we should be able to reuse it across shape and draw functions. We'll have to define some overrides though. Okay, so when I'm calling draw, I will pass a context here. The same with shape. Here I will pass context. Same with draw. I don't know what the model did here, so I'll undo this. Okay, so now those kind of heavier operations can be avoided. Okay, this distance to seconds is something that we could switch over. Timestamps. It's a lot of boring code. It's kind of necessary if you want to avoid re-querying the same state over and over. There is an issue. It's not updating the track when I scroll. This movement does not update the widgets. This updates. And now I crash. So this sort of animation waking is something that I think there is more subtlety here that I'm skipping. The point of doing this responsively is to have a nice pointer attachment. So hypothetically, if an object has multiple widgets, only one of them has to be updated responsively. All of the others can be updated like that. But still, there was something weird there. Seems like it's working now. Here we went through each widget that belonged to a track. I don't know why this would crash, so I think the crash could still be a problem. Okay, but that point is covered. So it not only caches these results, and okay, There is just one more thing. So we've done what we wanted to do. We separated those two classes. We want to do more cleanup in the, let's say, core Automat APIs. So I avoided this mechanism for passing the pointer to widget's parent when constructing a new widget. Each widget has a parent that is being kept alive. There should be a note here. So, logically speaking, this parent could and should be a weak pointer, but I'm keeping this as a regular pointer just for convenience, because that would be just a lot of upcasts all over the place. This is only temporary. Like, eventually, this will not even be any sort of shared pointer, any sort of smart pointer. It will be a reference once we finish. Or a pointer, actually. Not sure if this is worth it, but it's a very common pattern. I think we should use a lot more of those contexts. They never caused problems for me yet.
Stella Harbour says,
What is it?
You mean what I'm coding in general, or what I'm referring to right now as this context?
This stream.
It's described somewhere below, but you're lucky to arrive at a time where it actually builds. So this is a desktop automation tool composed of multiple objects that can be combined. So if you know AutoHotkey, AutoHotkey is an excellent automation tool. Strongly recommend. I use it a lot when I play games. However, it requires a programming language to operate, and this interface allows to do macros without any programming language. So I have all sorts of shortcuts that allow me to do stuff. I can, by pressing F3, I can, for example, record a macro that will press space a couple of times. And then I have the hotkey for F4 hooked up, which can start this macro.
But it will be cross-platform.
Yeah, it works on Windows and Linux so far. macOS also is coming, and maybe even others, maybe even mobile operating systems. Yeah, so it can move the mouse. And when I was recording macro, I pressed F3, so it also has this short F3 kind of press here, and it can also press space. If I was doing something, it would actually send signals to the app.
Nice one here.
Yeah, thanks. So we're cleaning up the code. The functionality is mostly there. I mean, not all of it. We still need to support gamepads, gamepad recording and replay, and mouse is still not finished because we are only recording we are only recording mouse movement. The keyboard presses have to be manually kind of automated. So this is another thing that should be fixed. So I've just done a little bit of quote-unquote cleanup. I really dislike that it increases the amount of space, like more lines of code. More lines of code is not a cleanup. I added a lot of lines to code just to a single place to define this and to reuse some of those pointer lookups. But okay, it happened, it's committed. The next point is, yeah, I want to fix this constructor, this parent. So parent seems to be referenced in a couple of places. Okay, there is actually a note about this. It's a very tricky issue that is going to persist in Automat for as long as I don't fix all of those. It's just a lot of annoying work. But I will try to improve the interface right now a little bit. So from now on, whenever a widget is constructed, it needs to get a parent pointer.
TP Chica says,
Does lib license allow same tree compilations?
Let's see. They have a custom license. Actually, it has a very nice license. Yeah, looks nice. This is kind of like the... what's this? The BSD and MIT licenses. They have a completely opposite clause. One of them kind of requires you to properly attribute the source code, and the other prohibits you from referring to authors. Anyway, zlib license is very nice because it addresses the trademark issue. Trademark is a pretty tricky thing because it's expensive and it requires legal assistance to track. So making this part of the license terms is pretty nice. Trademark and licenses are probably different kind of legal mechanisms. Probably licenses have less enforceability than trademarks. what we want to do. And that simple change should break a lot of code in Automat. Like half of the places where we are referring to parent, we are doing this because we just need a better way to construct objects. Make PTR keyboard. So keyboard already gets root widget in its constructor. So we don't need to set it here anymore. Like ton of places, like 46 results I see. And fixing them is actually rather mechanical work. So instead of doing this right away, I will queue some video. There were more videos from Better Software Conference, so we will watch them now. And I will also grab some food maybe. So here we have some. We watched those two. I guess the next one is this Ginger Bill. First, I will grab some fruit. So in a moment we'll watch this.
Diego had a good talk emo.
Yeah, I think I've seen it referenced in one of the subsequent ones. I mean, just looking at the thumbnails, I love it. I love the thumbnail. So this is how software should work. It should be as small as possible. I've seen file pilot used by in one of the later presentations. Really impressive, and yeah, I'm looking forward to this one. Okay, be right back.
Zephyr Book says.
Hey, Knight. Okay. Let's go.
Hello and welcome to the Better Software Conference 2025. Today's talk is by me, Bill Hall, and it's going to be on tools of the trade. So firstly, who I am. I am Bill Hall, commonly known by my moniker online as Ginger Bill. You can probably guess why. I'm also the creator and main architect of the Odin programming language, a programming language which is for modern systems. It's a systems level language, and it's effectively a C alternative for the joy of programming. I started working on this about 9 years ago, and wow, how far has it come? And I'm also currently working with and at Django Effects on numerous different projects, such as Embergen, which is our real-time volumetric smoke and fire simulation software, which is used.
Odin's really nice.
Film,
I just looked at it from
TV
afar,
industry.
but
Mostly games.
all of the choices in Odin,
We also have GeoGen.
it seems like the perfect language. It seems better than Go, which is just really something. It's like Go, but more closer to hardware, let's say. It focuses more on memory layout, which Go forgets. It gives you manual memory management, which Go forgets, and it's generally still from the group of Algol style languages. So you have functions, braces, variables, and so on.
Which is our real-time terrain generation software. We also have LiquidGen, which is our real-time volumetric liquid generation software, and IlluGen, which is our real-time procedural animation generation software, and many other things specifically tailored for game developers. And it also is in general, my general background is in quantum mechanics, specifically in quantum metrology. So I was dealing and developing things such as quantum clocks and quantum gravimeters back in the past.
Quantum mechanics, I've seen some articles where, I mean, I'm more from an algorithmics background, but some of the algorithms are, there are some quantum-inspired algorithms for doing stuff. They are not record-breaking in anything, but they exist, and they are interesting. They are randomized. It's a category of random. There is a whole category of, I don't know the English name, for randomized algorithms.
Past. But now I'm a full-time programmer instead. Also, whilst I note, you may have noticed this is a recording and I'm not actually at the conference. Unfortunately, I was meant to be there, but I had to have an appendectomy to get rid of my appendix. So unfortunately, I'm now recovering at home and not in lovely Sweden. So I'm sorry I've not had to be there. So I hope the conference is absolutely wonderful at the moment and everything is going well. So, shall we get hit on? So first, why are we all here? Right, what is the whole point of this conference? What is the main thing that drives us to even be here? And I think I can sum it up in one word. Craftsmanship. Fundamentally, we're all here for that thing. We honestly care about our work. It's the first thing we have to do, right? We care about what we are doing. We care what we put out to users. And pardon my French, we don't want to put out shit. We want to put out good quality stuff that works. We see the enshittification of software and how software is getting worse and worse and worse every single day. Software that is effectively the same functionality as it was 20 years ago, it's like Microsoft Word, and it has virtually no more functionality, but it's so much slower, so much worse, so much buggier. Everything is worse about it, right? And it's okay, what else does it do nowadays? Oh yeah, nothing.
TP
really.
Chica
It
says,
just made it
I
a little
don't
bit
know if it will
prettier,
have any use
but
for
it
this file
works.
other to force
And
AI to
who-
not
this has
use
been
weird
into anyone.
old
It's all
versions
because-
of projects.
URL.
Check this. One of those times I will open a malicious URL. I actually wonder, so agents, they typically remember how to use different libraries. I wonder how good they are at remembering versions. You know, because the usage pattern often change. A new version often introduces a new, completely new calling pattern. Especially in C++. This is especially in C++, where you have just so many ways to construct an API. Okay. Back to the video.
Because the people who are programming this stuff don't care, pretty much. And the people they're being managed by don't care or anything. All of it, throughout the lane, they don't care about the thing that they're selling. And they can get away with it. That's the problem. They get away with it. But that's the thing. We're here at the Better Software Conference because we want to produce better software for people to use. Fundamentally. That's why we're here. But the other thing that's also a little bit more
I started
specific to
typing
us as
fetch
well is that we
content
actually
and
care about
DevStroll
hardware that
auto-completed
software
everything
is ran on.
correctly. So I might keep my sanity
This isn't some
levels.
abstract thing. We aren't pretending that, oh, we don't know what we're running on half the time. I usually pretty much always know what the hardware you're running on. So why don't we just actually understand and make our software work for that, rather than some abstract machine that doesn't really exist? And again, all of this is craftsmanship, and we strive to be better at our craft. So I wanted, before I even started with my talk, I wanted to do a little bit of showcase of some of the software from some of the speakers at this talk right now. And this is just a small selection of some of the ones that I like the most, pretty much, just to keep it small. And I don't want to go on for hours. So the very first one I wanted to talk about is from Andrew Rees, who's a very good friend of mine, but it's Whitebox. As he would summarize it, is to watch how your code behaves as you write it. Whitebox, for people who have never used it or seen it before, please try the link on there. It's whitebox.systems. It's effectively, if you think of a debugger, of a visual debugger, it's more than just that. It will track the data as you are programming through it and seeing how it modifies and see how it evolves and so on and so forth. This is one of the best pieces of software I've seen for programmers to visualize what is actually happening on with their program. This is the first step, in my opinion, towards proper visual programming. And it's something which...
Let's check this out. Whitebox systems. So here are watch expressions, and the debugger lets the software run and keeps plotting the watch expressions from what I see. On the timeline, we have how the value is changing. Amazing. I cannot full screen, unfortunately. But I see in the thumbnail that we have rows, again, related probably to different variables, and it's showing them in the timeline below. It's nice. Very nice. I maximize this. I cannot. But yeah, standard debugger features. So breakpoints. This stuff, the watch expressions as a graph. It sounds like something that's very cool. I can totally see how this could be useful. CD stack. Oh yeah, stack is actually interesting. So how can we see the stack as it evolves over time? Okay, there are like stack frames, I guess, in here. Oh, and this one can be maximized. So we have parsing for a small integer. Yeah, and this is what I meant. Each variable is displayed right here. Speaking of stacks, stacks are actually a problem for me because in the assembly, for two reasons. Stack is something that makes it hard to sandbox a piece of code. A piece of code which uses stack can easily corrupt it. Or we cannot just run it. I mean, we can run it, it can just corrupt the parent code. And visualizing stack in a UI is tough because stack behaves in a funny way. Sometimes the child functions can refer to the values stored in parent stack frames. Sometimes, but most often they don't. Most often they only care about their own stack frame. So this structure is very, it's most interesting at the very end, and maybe sometimes it has pointers pointing very far up the stack, because stack goes down, right? Nice. White box, nice piece of technology.
I've not ever seen properly done, especially on a generic case where it'll work with your C and C++ code out there. The next one is from Vyacheslav, and I apologize I can't pronounce your surname, but it's called File Pilot. Now, most people who have ever used Windows probably use the File Explorer, obviously, because everyone probably uses it as the most used application on your actual computer, most likely. And you know, nowadays with Windows, it gets worse and worse with every single version update. And the File Explorer is no different. In fact, it is so bad now and so slow and so buggy, and it crashes all the time. And Microsoft, again, don't care. They don't care. But Vyacheslav has cared and actually tried to make an alternative. And not just that, this is engineered from scratch, from the bottom up, to be not just feature parity, but so much better. It has so many more features, so many more functionality, and just again, so much faster. And a tiny little executable, which is, I can't even remember, it's only like a megabyte or a few megabytes in size. It's tiny. And it does so much more than the bloated Windows File Explorer. So please check it out on filepilot.tech. There's also the project by a good friend again from Ryan Fleury, which is the Rad Debugger project. Now, he works at Rad Game Tools, which is now owned by Epic Games, but specifically he's working on a brand new native user mode graphical debugger. Currently it's only working on Windows, but there are plans, and they're going to be soon, again at the time of the recording it's not available, but it's going to be working on Linux and Mac. So this video on the side here, you can probably see, on the left is him building the Rad debug from scratch, then debugging a programming in it, and already started. Well before the time that even Visual Studio has even gotten off past its splash screen. This is showing you how slow stuff, even Microsoft's tooling is. Like Visual Studio is that bad and that bad slow, that if you can compile the entire debugger, and by the way, if they do the same amount of features, if not Rad debugger.
It's fun. If I did work at a large company, so now I kind of see how it works from the other side. The source of this bloat is that the company is divided into many, many teams, and each team, or each even person, has some goals, like some things that they want to achieve, to do. And when each of them, in isolation, implements their solution, when combined, it leads to experience similar to what you get in Windows nowadays. It's just a system engineered by thousands of engineers, each focusing on each individual part, with very little top-down kind of direction. That's how it ends. So smaller projects, like the fewer people you have on a project, the better it's going to be engineered.
Builders even more nowadays, because especially with what it's being capable of with all its visualization tools, it's there. There's also, as part of the tool, because it's been debugging, they've created their own new RAD linker, right? A new linker which is faster than anything else available on Windows, and it's already been used in numerous games on the by the Epic Games, obviously. Fortnite is the one that I can think that is the most prominently used by this already. And lastly, I'm just going to showcase myself, which is again the Odin programming language. This is 9 years of my life now at the time of recording, and yeah, I wanted an alternative to using C++ because I was getting so fed up of those languages, and at the time there was no alternative for a manual memory management language, which that was kind of in the imperative procedural domain. There wasn't, so I had to go create my own, and thank goodness that I have. Not just people at Django Effects, where we have over 24 employees now, and half of them are using Odin on a daily basis, but Odin is being used by tens of thousands, if not hundreds of thousands of people. It's a bit surreal, I will tell you that. Something that I started on a very weird night, let's put it that way, and it's now gone here. So if you want to check out Odin, please go to odinlang.org, and then you can try it out for yourself. So, firstly, okay, we're all here because of craftsmanship, great, but why this selection of people? Why does all of this exist? And it's because of one thing. It's called Handmade Hero. Handmade Hero was an ongoing project by Casey Muratori about nearly 11 years ago, and the whole point was to create a professional quality game from scratch with accompanying videos where he explains every single line of code he writes. And also made the source code available at a little bit of a price, but you could also just watch the videos for free. They will stream live on Twitch and then upload to YouTube.
Yeah,
And again, the text from the trailer was what captivated us. When I saw
I've been
this trailer,
following
I went,
Handmade
yeah,
in
that's what I want.
something
And
like
just like
almost 10 years ago.
And I'm just going to quote it here to begin with, because even in the trailer it's silent.
But I think the videos were actually being, I don't remember, because I think I paid for something. So either the videos or the game were paid back in the day. Maybe now it's different.
I was little. Games were made from scratch by people who loved them. There were no license engines. Every pixely little hero was coded by hand. My 30 years of game programming were inspired by this way of life, and I believe it is worth passing on. So I am starting the project to help preserve it.
I'm not sure if coded by hand is what it specifically means. People used to have slower computers back in the day, so they optimized the games more out of necessity. So now they run very fast. But if you run them on a very old computer, they were still laggy and buggy.
And that man again is Casey Muratori. So for people who don't know who he is, also, hello Casey, welcome to Better Software Conference. He is a programmer who has been specialised in game development and game engine research over numerous years. He's worked on many projects at Rad Game Tools, such as Granny and Bing 2, and he's also worked on games such as The Witness, made by Jonathan Blow. And beyond Handmade Hero, which I've just talked about, he is known for popularising many different concepts, such as immediate mode graphical user interfaces, which are very popular nowadays. The N-way linear quaternion blending, which is effectively, instead of using S-lerp, spherical lerping, he would just do normal lerping and then normalizing over the top, and it works out pretty damn well. He also is very good for popularizing, implemented the GJK algorithm, which is very mainly used for collision detection with shapes. But most recently, he has been doing a numerous Substack series on computer enhance. This is effectively explaining the internals and lower levels of how computers work and how to deal with that as a programmer, and actually better. So I highly recommend checking out all of these links. Again, the link to this slide is available I'll tell you at the end of this presentation. But I don't want to just talk about this. I want to say that look, Casey Muratori changed my life pretty much, right? And I think he changed the life of so many people at this conference right now. The entirety of Handmade Hero made me reevaluate how I was programming in the first place. He effectively kicked me out of this very dogmatic way of thinking. Like I was just following the people who I thought were experts, and he just went, no, start thinking for yourself. And then I started questioning. I was like, oh wow, I was actually going, oh, this isn't common wisdom what I'm learning. It's common just things. It's Chinese whispers. It doesn't mean it's actually good. And again, it reinvigorated this self-reliance, so that when I was as a programmer, I would get so much better. And again, clearly we're all here because a lot of us made a community around this series, and the general lessons that we learned from it, and the general ethos that we had, this handmade ethos that we started calling it. But that's been 10 years now, maybe nearly 11 years of my life, and I've made some very good friends along the way, and I've started a career and from it as well. Like Django Effects is effectively people, the initial people. In fact, most of us are people who know about the Handmade Hero series and came around from that. And we're not alone. There are many other people and companies that are because of that. And I just want to say thank you, Casey. Thank you so much. And I bet there's so many people in the audience right now and people watching who just want to thank you for everything that you've done. Thank you. So let's get on with the talk, shall we now? Let's talk about the tools of the trade.
It's a longish introduction.
This is the name of my talk, and you'll understand why I framed it this way to begin with. So when people think tools of the trade, specifically in programming, usually the first thing they may be thinking is, oh, the computer I'm using right now. I'm using a particular MacBook Pro as my laptop computer at the moment. Or they might think, I need a better, or they're talking about the keyboard or the mouse or the display. A lot of this, again, these are tools that you're using to program, obviously, and use everything like that, because your computer is a tool. The keyboard might be, but a lot of these maybe also, like, you could put them in like the mouse and the keyboard they use and the display. This is maybe more ergonomics than general tools, but again, ergonomics are important, but not the topic. You may be thinking a bit more abstractly, going to software. I'm not going to hardware, go software.
Tools of the trade, I think it's some kind of idiom. I'm not familiar with it completely.
They use to program. That's the tools of the
I can
trade.
only
And
guess
yes,
from
they
the
are.
words
They
what
should
it
go a little
means.
bit further down. Okay, no, it's the debuggers I use. It's the tooling around that to actually understand how my code is working and such. But yeah, that's a tool, obviously. You may be even a bit more, you're like, no, it's actually the languages I use and the compilers I use or any of those sort of things. It's like, okay, again, that's still software, we're still getting there. I'm saying, like, okay, we're going to go a little bit more abstract still. The next level of abstraction could be how it's algorithms and data structures. And I like, okay, many people who know me, I love Niklas Wiert's book, Algorithms plus Data Structures equals Programs. And I think it's a very good way of understanding what a programming is, if conceptualizing it as those two things, algorithms and data structures. But again, it's abstract still. It's not, you implement those and they're still kind of general abstract entities. But like, look, there's something that most of you in this audience, in fact, most people in general, neglect. And they even forget that it's a tool, it's an abstract tool, the thing we need to have in our metaphorical toolbox. And that thing is mathematics. Yep, all you people, you're going, oh no, mathematics, this is a maths talk, isn't it? I'm like, yeah, yes, welcome, yes it is. But before I start, I want to say, look, there's a lot of lies we tell ourselves and others, specifically about mathematics. Like the first one, when many people try and get people...
It's a common question, like, do you really need mathematics for programming? A lot of people keep saying that, no, you don't really use it day to day, but you do all the time.
Algebra, right? And also technically modular arithmetic. But most people know that, right? Good example of modular arithmetic is your watch, and that's effectively mod 12. But like, there's loads of things about mathematics, because again, a lot of people say they don't know this because they don't really know what maths is, or mathematics in general. The other one is that, you don't need that much mathematical knowledge to program well in the first place. Again, yes, you do.
But only if you're working on boring stuff. Interesting stuff always involves mathematics.
As soon as you start to make any more complicated program, you will need it, right? Make a game, you'll need to learn linear algebra at a minimum. Okay, you're making some accounting software. Great, you need some more, general arithmetic. You may even need to know some accounting, you may need to know loads more mathematics. It's like, okay, all of this is like, whatever you're doing, you still need mathematics. And you need to be good at it. The other one is sometimes people tell themselves is like, oh, I can learn as we go along, right? I'll learn it when I need it. And that's, yeah, that gets you quite far, to be honest with you, right? You may be good. It doesn't mean you're going to be great. It fundamentally is, how do you know you don't need it unless you know it exists?
Says.
I guess it
There's a
depends
lot of
on
areas
what you
of
were
mathematics you don't
doing.
even know
I'm a web
anything about.
developer, and there is not that much mathematics.
So how are you going to learn it if you can't even come across it? And lastly, there's a lot of people will go, oh, well, I was never good at mathematics at school. So
It's probably about what the web app is doing, because web apps typically operates databases, right? So not much there. Maybe a little bit, but not a lot. But if a web app tries to do something with graphics, sound, it pops up. And algorithms, I thought they are part of mathematics. It's a very... it's more mathematics than computer science. I mean, it's a formal science. Algorithmics. You don't need computer to analyze a complexity of an algorithm.
And this arrogant ignorance that people have. It's like, you don't care about your craft? Really? Just, look, you're programmers, right? There's a lot of things, even at school, people will always ask this question of, oh, when am I ever going to learn this, sir? When am I going to need to learn this thing that I need to know? I don't think I'll ever need it. I think it's for many people.
Yeah, I hear this all the time.
You're a bunch of programmers.
Very short-sighted.
You don't need a lot of this. So stop pretending that you're just the average man down the street. You're not. We're going to start learning. So, I'm going to teach you by an example that you have a set of skills you need to learn, right? And there is no excuse. So get warning, there will be mathematical notation, but throughout that you can understand what the message is going to be. Right? So firstly, the topics I'm going to cover anyway, I'm going to talk about some calculus, specifically discrete integrators. That's what we're going to actually finalize at, by the way. And the next is going to be linear algebra, and specifically how matrices and graphs might be related somehow. But again, this is the important lesson. This is the thing I'm going to try and get through to you. What I'm going to do today is not a lesson. I'm not going to teach you these things. I am just there to give you an overview of mathematical topics that I expect most of you in the audience and watching at home know nothing about, most of you. And the main objective is for you to know and go out there and learn more mathematics to broaden this mathematical toolbox, to add more tools to it, these mathematical tools, so you can become better at your craft. Again, this is not me going to teach you it. I'm just going to show that most people, you don't need to know. And again, I don't. I need to learn more mathematics myself as well, because it never stops. And when I learn more stuff, I can find more uses for it, even as I'm building. Well, I wish I knew that sooner, because that would have solved this problem, this problem, this problem. But how are you going to know? So let's start with the first one, shall we? Calculus. Specifically, we're going to do something called lerp smoothing. So this came about when I was talking to a guy.
This is something I really dislike about education. Sometimes people overly complicate stuff. I think in academics, they do this because it's like part of the culture, but I see no reason to do this online. There's no reason to involve integral or calculus in lerping.
My friend Ryan Flurry, just over 2 years ago, and he was doing this kind of lerp smoothing in one of his, I think it was a game I think he was doing. So lerp smoothing, for people who don't know, is effectively, if you've heard of lerps, this is linear interpolation, by the way, you're going from one point to another. And the lerp smoothing is effectively, as you get closer and closer to the target, it'll slows down, but you're moving towards a target. So the dumb approach most people do, as you can see the code here on the left, is you have A equals the lerp between A and B of K. Now if we expand that, really, right? You've got A plus B minus A times K. That's effectively what this code is doing. If you know what A plus there, you can do the A plus equals B minus A times K. Now, let's play this little animation to explain what this does. So you notice as it gets to the target, it gets slower, and then once I get near the end, I just switch back. But what you may notice is this isn't frame rate dependent. All of these here are running at different frame rates. So the one on the left is my native, and then it's cut by half, a third, fourth, fifth,
There is this
sixth,
exponent function.
and it's not frame rate.
We use this a lot,
whatsoever.
actually.
At different frame rates, they're going to be doing different things.
But it
at
doesn't
different
require
times.
calculus, it only requires
So many people in the
derivatives.
audience have probably heard something about like the delta time. That's the time between the current frame and the previous frame. And they've always learned that. So oh, multiply by dt, magically things get themselves fixed, right? So let's try that. Let's just try that little animation. And if you look at it, it is slightly better. But we'll just leave it to run for a few seconds, and notice it's starting to drift. So yeah, that dt thing, times by the delta time, is a good approximation, but again, it's still subtly frame rate dependent still, right? But the question is, why? I thought times by dt was the solution, right? Well, in this case, it's not. So,
yeah, this is why a lot of people use timeline-based animations, but this approach is way better. I mean, it's not explained here. I mean, this is the formula,
so I'm now
the one on the bottom.
That A plus equals thing has now been written here as the delta A. That's the plus equals saying the change in A. That's what delta means. That B, which is your target, minus
this is for frame-independent animation, like
constant times delta T.
But there is a funny thing. The funny thing is that if you optimize your game further, you have this problem with frame latencies and stutter. If you animate a game and each frame uses a different delta, which can happen, right, when you have spikes, lags, this sort of stuff, the resulting animation is stuttery. It's not smooth. Like when an object moves, it doesn't just move, it moves, but it has this very subtle glitching effect to it. So games that actually try to have also smooth animation, they don't use this. They instead use fixed time delta, and that's it. So it's a nice solution for a problem that should be solved in a different way.
That is where we're starting from. That's what we think the answer should look like, because it kind of did look correct initially, and then it started to drift. So if we put the delta t onto the other side, divide by the size by delta t, we get delta A over delta t now equals this equation. Now, for people in the audience who already know this, they would go, wait a minute, that looks like a differential equation. And that's right. So if we change those deltas into d's, we have now got a differential equation. So this is the technical term for it is a first order, which means there's only one differential, d by dt, that's it. And it's linear, means there's only a coupling of a term in there. Ordinary differential equation, right? So ordinary rather than partial. So all those words, fancy words mean, but that's what we've got here. Now, when you have got a differential equation, you want to usually solve it to find out what the actual equation is. Now, I'm not going to go through integration to say how to do this by hand. One of the tools in your toolbox as a mathematician we have nowadays isn't just pen and paper and your mind. We have tools like Wolfram Alpha, a brilliant, beautiful tool. I highly recommend most people check out. And effectively, I just typed in that equation and got the solution. And it told me that that equation, A of t, so A as a function of time, can be expressed best as this case. So it's equal to B plus some constant times e to the negative kt. So this is e is the Euler number, and the
exponential function is also the easiest to integrate because the integral of exponent is the same exponent multiplied by a constant.
This is effectively the general solution to our ansatz, is what we call our kind of educated guess. Now, it's in a form because we've got this C1, this first constant. We don't really know what that means.
Am I only
So
one
if
who
we
uses
actually solve
Docker
it
just to
knowing that
verify I
the
can
A
build
zeros,
on
but time
different
equals
distro
zero,
such pray?
our equation should equal what the initial A value is. So if we rearrange it, we actually get it into this form here, right? A of t equals A of t times e to...
I had no idea there are distro Docker images. I mean, makes sense, right? Docker has images for different OSs. And that's nice. That's a nice way of testing stuff.
Negative t plus b of times 1 minus e to the negative kt. And when you
Even
do
Gen
that,
2 has
some of you in the
one.
audience will go, wait a minute, that's a lerp. And it looks...
It's probably the most useless Docker image. A Docker image where you load it, and whatever you want to do, you have to compile it from scratch.
It is a lerp, in fact. So we started off with a lerp, and now we've got a new lerp, right? But again, this is still not what we wanted, because we wanted this discrete differential form, so we can just keep adding increment to on each iteration, right? Rather than having the perfect generalized solution. So if we rearrange it to get it into a form that kind of looks similar to what we had, it'll look like the following, right?
It has
A
says
plus
looking amount of
b minus a
pulls.
times this new term. So we notice that this new lerp parameter has this 1 minus e to the negative kt, right? It's not just the kt anymore, it's this 1 minus e to the negative kt, so it's a little bit fancier. But it's still not the incremental form. So the way to do that is we need to just replace the t's with delta t's. So if we start with all this, we start at a0, and then this is what differentiation is, by the way. You make these small little parts, you make a little bit of a chunk, and you start off this delta t, and you put that in all the valuation, we get this delta t. Now, we're starting from the 0 point, but that was arbitrary. We evaluated everything at a0, it was an arbitrary thing, and we're going to know that it will hold for all a. So that upside down a is...
So the stuff that he's describing is in
right? So thus, we get this solution here. So the change in
animation.hh in Automat. And this is the...
1 minus e to the negative to k delta t, right? That's our solution. That is actually the solution to what we started with.
Exponential approach,
Now,
this function.
more frame rate independent.
There is also this convenient function, exponent minus 1,
To the original
which
equation.
can be used
So
to
we just
compute
had
this value.
K delta t initially. Why is it now got this exponential function
I
in here?
forgot
It's like
on
the negatives.
OpenSys you have
It
to
just looks different,
manually
right?
install linker.
What's going on? Well, there's a trick, which many people may not know, is that you need to know something called like the Taylor series. This is what you can do when you expand the function that you have around a point, in this particular case we're doing it around 0, and seeing how we can express it in terms of a polynomial. And it turns out that 1 minus e to the negative kt, when you expand it out, starts with k times delta t minus k delta t squared over 2 plus k delta t cubed over 6 minus and so on and so forth. Right? So this is how we expand it and turn it to a polynomial. Now, because we're doing this for people who want to know in the audience, this is when you evaluate a Taylor series around 0, it's sometimes called a Maclaurin series, named after the Scottish mathematician Colin Maclaurin. Yes, that's his real name, Colin Maclaurin. It does roll off the tongue quite nicely, but yeah. But usually in general, we'll call these Taylor series because we can then generalize it so we can evaluate at any point, not just 0. So if we plot that Taylor series and replace that exponential and put the Taylor series in there, we can start to see that our original guess, our original ansatz, was just an approximation of a lower order equation, right? So we effectively had that k delta t plus higher order terms, so the square terms, the cube terms, the quarter terms, and so on and so forth. So if we just understand that, we can understand why our guess was pretty good initially. It's just as time went on, those higher order terms were not being added to the contributions, so they started adding in more and more errors, right? So if we look back into our final code, we just replace that k dt part term with the 1 minus the exponent of negative k times dt. Or if you want to expand it out, not use the exponential function, you could just add all those extra terms in manually if you wanted, up until the point where you say, that's good enough. So we've actually got a nice solution to this problem. We're already there, right? So here's our improved form, and I'm going to start the animations for it, shall we? And you can see these have got the things 120 hertz, then it goes to 60, 48, 30, 24, 20, and it's much nicer, it's not drifting as much, but we do have a slight issue. We've got, looks like a 2 regime problem here. So the ones above 30 hertz are kind of grouped together, and the ones below 30 hertz and below are kind of grouped together as well. So there's no this tilting drifting we've had anymore, which is great, by the way, but there is this 2 regime system. Two-rate system is actually an artifact of how I've kind of written the code, but also they aren't fixed frame rates. So that's the reason why it's the case. You can fix it if you take that into account, but I wanted to keep these examples pretty simple, so I wasn't trying to...
The way that
cheat too
AAA
much.
games do this is they don't use the clever math. They use the fixed time step at some high number of tick rates, which is often higher than, or slightly higher than the display refresh rate. Something like 100, especially in multiplayer games. This is used. Because it also helps with data synchronization. With fixed time step, synchronization of compute on two different machines, it's much easier.
Right. But that's great. So why is this new method much more stable? Well, if you actually plot that comparison, that k delta t term compared to that exponent term, you get to see it. So at the higher frame rates, like 144 hertz, 120 hertz, well, it's like 0.3, 0.4% difference between the numbers. All right? But as you get lower and low frame rates, the difference is big. So even at 10 frames per second, that difference is now 5%. So after 10 frames, you're about 50 odd percent out. And then after 100 frames, so in that case, 10 seconds, you're more than 5 or even 6 times out. It's compound interest at that point. And it just gets worse and worse with the errors. So if you can minimize those errors by having a better method, oh my goodness, just do it. And it will just be a much better thing. But again, you may want the simpler method, again, but you need to understand what errors and costs you're taking into account when you do it. Notice this difference is per iteration, not in total, because in compounds and compounds, that's why it starts diverging. That's why it does looks like a seesaw as it goes up and down anymore, slopes rather than keeping in track. But here's the thing, a lot of people shout in the audience already telling me, why don't you fix your time step? Well, the thing is, that's fine. Fixing the time step is a good solution if and only if you never change how much that time step is fixed to, right? Because if you need to change it and you actually change the logic, that might be fine. You may think, I'm going to just fix my time step to 60 hertz. But now it's like, great, now you support the logic to 60 hertz, but a lot of people have monitors now which are well above 60 hertz. Again, for the display I'm working at the moment, it's 120. I want to hope that was 144.
Yeah, but the display can be decoupled from logic. Game logic can run at a different fixed
frame
step.
rate that's lower than the refresh rate of the monitor, you're going to start seeing those stutters quite easily. So when you move to a lower fixed time step, things are going to start looking weirder as well. But again, if you're doing the correct integration in the first place, rather than fixing it to fix this again, add a bit of determinism, you can get a lot of help to get the correct answer in the first place. And just relying on that fixed time step is fundamentally a bodge, right? Do not bodge your code if you don't have to. That is kind of the message.
This is wrong. This is wrong.
As well, man. Don't bodge your code if you don't have to.
I mean,
So
this stuff is used by multiplayer games because multiplayer is... So first of all, variable time step leads to stutter in animations. It's just worse animations. You shouldn't use variable time step if you can avoid it. And it also makes multiplayer much harder to implement. The advice that he's giving is just bad advice.
But even then, we're going to still show you the fixed time step approach. Now, I'm going to make the time step 6,000 hertz, so updates 6,000 times thing, and they're going to show them across the different frame rates. And this is generally the effect of the code we have here. This is just Odin code, but slightly same thing. And you can see it looks pretty nice already. It's pretty smooth across all different frame rates. But again, we have this two regimes thing still happening. But in general, we don't have this.
I'm not sure if you can see this. At 60 hertz. My display is also at 60 hertz. But you can probably, in the movement of those circles, you can probably see the stutter. The stutter is caused by the mismatch between the frame rate that he's streaming at and I'm streaming at. We are streaming at 60 FPS. Or recording at 60 FPS. Maybe he was recording at 30, I'm not sure. But when the refresh rate that he's simulating performance issue here. When it mismatches the display refresh rate, and it's not an even division of, display refresh rate. For instance, when you display something at 30 Hz on a 60 Hz display, it will display 2 frames, or 2 frames, 2 frames, 2 frames. But if you have a refresh that's happening at, 50 Hz, then you will have a couple, like 5, 1 frames, like frames which is presented for the duration of 1 frame, and then 1 frame is going to be presented for the duration of 2 frames, and then again. So there will be this, even though the simulation is happening at a smooth 50 Hz, and he's advancing the animation by a smooth 50 Hz time steps on the display, this is going to be displayed for a variable amount of time. So a user, like a player playing a game, is actually going to see stutter. This is why fixed steps are typically better. And this is why when a game has performance issues, it's better to degrade in a discrete time steps. So when the performance of the game degrades, instead of trying to push it as high as possible, and for example rendering at 50 or 40 Hz, it's better to just drop to 30 and keep stable 30 Hz.
This diagonal drifting that we had previously. But again, it's still, fixing the time step still doesn't fix all of your problems. You're still going to get some other ones. And noticing even at the different frame rates, it's still going a little bit weird. And there are reasons for that as well, by the way. It's not a mistake. There are reasons for it. Again, this is exercise for the people at home to know. So, we're going to think about other methods. So the thing is about what the approach that we just done today, effectively, is a specific type of a discrete integrator. Now you may be asking, does the approach that we've just touched always work? The answer is no, it doesn't always. Because the equation you may have may be very hard to figure out. It might not always be impossible, it just might be very hard.
Yeah.
Or it may
Spring animation is way harder. It's still possible to derive the math, but it's harder.
Here is technically a form of a forward Euler method, and specifically it's actually a special case of a first order exponential integrator, because it was exponential in that case. Now exponential integrators have loads of research going on since the 60s, but in general they have their own issues as well. Now if you're dealing to make your own physics simulator or something like that, the forward Euler method does have its issues, but there are improvements. So you may want to do forward and backward Euler methods. You may want to do the wrong cutter methods. So you can have more. Again, the whole point of these methods is to have better stability or better compromises or
overkill.
They do. So again, I highly recommend you go
all of this is overkill
on all of these topics.
It's a waste of time.
Because you'll learn a lot more about the shortcomings,
for animations,
trade-offs, and the benefits of all of these different ways of doing things. And finally, I'm just going to start with something a little more complicated, just to show you what if things are really complicated. Like for instance, what if our B value...
It's a great way to waste a lot of time and to make the result worse.
Keeps changing, right? It's not a constant. But when you integrate this, it gets a lot more complicated, right? We start from our ansatz, and then we find the actual solution from the ansatz. We get this really complicated differential equation, which is still like unsolved.
So this is delta t is delta times...
So we plot in what b is to our
It's the same.
Like say b is a sine function.
B
all it does
is a variable function now. I see.
Complicated solution, right? We could have guessed at what it was when we put them into the equation. We could have just said this was a sine and then think this was good enough for our answer.
So this is something that exponentially approaches a wave.
So going from our ansatz and then putting in the actual solution gives us something a hell of a lot more complicated than we realized.
You want to see how it looks?
You can see how much it's going to drift even
This is actually interesting.
Than from our starting position. This is why it's always good to actually show, okay, what is the real solution?
Because if I wanted to animate something that follows a wave, I would just use a sine function. Sine has this property that the derivative of sine is cosine. So sine tends to produce more trigonometric functions in its derivative, and its integral as well. I actually wonder what's the reason for adding this exponential tracking of the sine function here.
Actual solution to our problem, and what's a good approximation? And
because this could when you have something that's wavy and something that approaches it, it's just going to follow something like a sine wave with a smaller amplitude, I guess.
Or not even a good approximation. What's just an guess? Sometimes it's like, we need to get closer to the real one. And I like that. So hopefully this is the idea of why we're doing some of these animations, and knowing the mathematics that you're doing, it helps to know calculus, because this is all calculus I'm doing, right, at the end of the day, but you're making it so you can make a better product that works correctly. Again, do not botch.
Yeah, this is calculus, actually.
So that's the first part of the mathematical
But
section.
for LERPing, you don't need calculus.
Talk about, right? If you've got any questions, please contact me at any time. Just that's it. But again, the second part I want to talk about was linear algebra. When I was planning to do this talk, I was having a lot of people ask me effectively two things. Like, oh, could you do something on linear algebra? And some people say, oh, could you do a thing on graph theory as well? And then I thought, okay, these people don't understand there's a relationship between these two. In fact, there is a direct relationship between matrices and graphs, right? In fact, these two things here, right,
Which you learn
the matrix
during the first week.
The matrix on the left and the graph on the right represent the exact same thing, in fact. So then you go, some people go, oh, okay, obviously that makes sense. And then some people go, does it? Right? So to explain what a graph is at the end of the day, for people who don't know, graph is kind of, it has all these edges, and these, in fact, these are directed edges with weights on them. So that's what the numbers represent. And they've also got these nodes, that's the green dots are for. And that these edges are pointing towards the different green dots to show a relationship. Now the matrix is a little bit more abstract and just has numbers in a 2D array. So what's going on? So people don't probably guess, you notice that the column here, the first column, corresponds to the outgoing edges from a node. In this particular case, it is the vertex 0, the node vertex. You'll hear node and vertex interchangeably most of the time, right? So again, that 0.6 is representing as the going back to itself. The 4 is represents from the vertex 0 to vertex 1, and 0 is not on there because there's no way of going from vertex 0 to vertex 2. Now note, by the way, the convention I'm using here is a column major convention. That's because I want to put the matrix operating on the left, applying to the vector on the right. Okay? Some people you'll see in some textbooks, they use row major convention. Again, it doesn't really matter which one you use. It's just a convention. And I'm just trying to be consistent with what I'm using. Now, the other thing you may have noticed is, if you look at the rows, right, those incoming edges represent, that row represents the incoming edges of the first node. So the 0.6 that is pointing to itself, we've got 0.7 going to that node, and then another 0.6 going to the other node. So hopefully the colours here, for again, the orange, blue and red, they make it clear. So that's kind of how you notice, oh, that graph is now represented with this matrix. Now, to make it even clearer, I can show you those columns with those vertices, again, V0, V1, V2, how they are related to the matrix. Such. Now, this relationship between the matrix and a graph has a name, and that matrix is called an adjacency matrix. Again, it's showing you what the adjacent nodes are with their connections with it. Now, you may be asking, okay, great, but what's the use of this? Because it just looks like, some like, okay, it's a nice little trick, but is it useful? And that's extremely so. Another way of looking at this is, I can change the graph and I've just changed the numbers on it as well. And I'm doing this now to represent them be probabilities, right? So now these nodes, those outcoming nodes, are effectively representing probabilities of going from one node to another, right? And how it traverses from going from one node to another. So that matrix is what we call a Markov chain. This is the matrix now, the matrix form of that, a Markov chain. So this is really great for understanding. Markov chains are very useful to understand going between different states in a machine. Now, a good example of this is maybe in a game, right? You've got different states in your game, and they have different probabilities of moving from one state to another, right? And if you can express it in just probabilities, like, okay, I'm starting from this state for my hero, and it's like, oh, there's a chance if I roll a die, it goes to this state or that state, right? And if you can figure out they're all different states and they can connect to different things, that's called a Markov chain. Another example is you could have a very bad, but it would work actually, by the way, a very bad system for knowing the weather. You could say these three states here, V0 is sunny, V1 is raining, and V2 is cloudy, right? Just say that's the simplest weather state you've got possible. Makes sense for England, right? So for V0, if it's currently sunny, there's a 60% chance that it's going to be sunny again tomorrow. But there's a 40% chance it's going to start raining, right? And then when we get to the raining state, there's a 30% chance it's now going to go cloudy the next day, or there's a 70% chance it's going to be sunny again. Or if we're in this cloudy state, that means there's an 80% chance it's now going to rain tomorrow, or there's a 20% chance it's going to be sunny, right? That's the kind of thing you can understand these dynamics by looking at the probabilities. So you can look at this matrix, and that matrix effectively represents this walk. That's what I'm going between all these vertices, these nodes, as we go through the graph. So because it's just a matrix, we can apply it to a vector. So we're starting from vertex 0, that's definitely the probability of 1. We apply the matrix once, we get the probabilities we expect. There's a 60% chance that we're in the V0 state, 40% chance we're in the V1 state, and a 0% chance we're in the V2 state. So that's great. Then the next question is, what if we apply M2, the matrix, twice? So we have 2 steps going through that iteration. Well, now we know it's 64% chance in V0, it's 24% chance in V1, and a 12% chance in V2. Okay, we're going to have to do it 3 times. Well, again, we now know all the distributions where we do it. So we're starting from, again, V0. After 3 steps of walking through this probabilistic graph, we now know there's a chance, again, 57.6% in V0, 35.2% in V1, and a 7.2% chance in V2, right? That's how this could work. And that makes a lot of sense. However, what if we actually did this infinite amount of times, that we kept stepping through this infinitely? Well, we actually find that this tends to actually a nice distribution. In fact, it's 9 30 seconds, 10 30 seconds, and 3 30 seconds in those distributions. And this place where we tend towards, after infinite, it could even be finite, by the way, but we're saying infinite in this case. This is called our steady state vector. Now, to make it clear, not all graphs have a steady state. The most trivialist one I can think of is, let's say you've got 2 states and they just ping pong back and forth between them. Like each state goes, this one, now this one, this one, now this one. There's never going to be a steady state because each one, they have effectively the same equal probability, but they're always, each state's going to be different each time. But again, this is very fine. So, but if we look at what this steady state means, mathematically speaking, it's effectively saying if we apply our Markov chain, our walk, the matrix, to the steady state, we get the steady state back. We don't change. Right? That's what that means. But again, if we rearrange it into a more conventional form, we can find, okay, if we're the matrix minus the identities, that's the 1, 1, 1, all the diagonals, 0 everywhere else, and then multiply it by the steady state, we get 0. The 0 matrix. Yeah? That's effectively what is going on. And it's very, how do I put this? A very interesting thing to know. So you could have a game, it's a good example of this, and you've actually, a lot of games can be expressed in spreadsheets, and that's how a lot of game designers do. They have a giant spreadsheet with all the probabilities, all the things. You could compute this and actually find out, maybe there's a distribution that you're aiming for, even if you play these numerous games, or if you're trying to make it balanced or something. This is what you're going to have to look out for, right? You're going to have to look out what happens with these. If you're doing a probabilistic, effectively finite state machine like this, where does it all tend to? Is there a steady state, or is there not? You might not want a steady state. You may want something that's not steady. You may want something that's pinging back and forth. Depends on what the game mechanics you're doing. Say it's a game. But the thing is, what I've just kind of showed you is actually called eigenvectors. You may not have known this. You may have heard of this term before. You may have not. This is the thing, right? Eigenvectors are something that kind of get briefly talked about in many linear algebra courses. But that steady state is a specific special case of an eigenvector. In fact, it is technically the eigenvector that is represented by the eigenvalue that's equal to 1. So that's a bit of a thing. But to know what this means is, show the eigenvector. It's like you have your matrix, you times it by the eigenvector, let's call it V, That is equal to some lambda, the eigenvalue, times by that
I'm
vector,
not sure
so it's a
if
scaling parameter, right? Now,
that
this
was
is a
the
very
goal
useful
of the
bit
presentation that
in
he
modern
started
mathematics. Eigenvectors
with.
and eigenvalues are effectively these things which effectively map to themselves with some scaling value. That's very, very useful to know. And again, a steady state vector is a good example of this. Now, to be very careful not to put all eigenvectors or represent a steady state. It's not the same thing. In fact, to get a steady state,
Yeah.
this property,
So
this very particular
I'm
case,
not a fan
means
of this approach
you have
because
to have an eigenvalue
he tries to
equal
explain
1,
something
and
in a
all
very
of the
fast
other
way
eigenvalues,
without any
if they change
pictures.
obviously, but
It's
all the
going
other
to just
ones have to
confuse
be less, have to have their
whoever's watching
absolute
this.
value be less than 1, right? That's what that means.
It's easy to make
Now,
mistakes
again,
when
not all
explaining
functions
things
that
like
have an
that.
eigenvalue of 1 mean applies
It's not the
they
best
have
way
have
to
all the rest
teach
be less
people.
than 1 in
When
absolute
he started,
values.
he said that he's going to.
But that's
He's not
what it
going
is.
to
It's
teach
mapping
those
to
ideas.
itself. If it's
He's
something where you
trying.
apply this matrix to a vector,
Actually.
you effectively get the vector back with a scaling. That's all that does. So that's a nice thing to know about. Again, it's a little bit of a topic, and I'm not trying to teach you what it is or how to even derive them. I highly recommend you read them
Exactly,
up.
this is what
So
was
that's just
done
more
like
of
for the
a,
past
this is what
20
it is,
minutes.
and they're actually pretty useful. So let's go on to connections, right? So this is another thing about
This is another thing, like doing one thing and then saying something completely else, like contradicting what he's doing with words.
graphs. So if you have a directed graph, which is again they're going from these nodes, and then they've got directions on the edges. If you can go from one node to every other node in the graph, and they all can go to connect to each other, we call this graph strongly connected, right? That means we can go from any state to any other state with some chance, maybe a probability or a certain weight or whatever. Now, if they cannot do that, for instance, you can go from, let's say, node 1 to node 7.
Yeah, I
node
honestly
7 can
not
never
even
get back
know
to
how
1.
to properly do this kind of presentation. So his goal is to, I get the message. The goal is to say that math is necessary, and the people who say that math is not necessary, they're mostly doing programming boring stuff. Interesting stuff always has math. I don't know. The point is to kind of show that those are more interesting things to program than the standard business-oriented kind of forms and widgets and web apps, this kind of stuff. Yeah, I have no idea even how to do this properly. It's just a very hard message to deliver. I think some good examples were those science popularizers from decades ago. I think they did a fairly good job, but they didn't try to rush through topics. This is probably not a good idea. And I think in most of those presentations, probably the most important part is the problem definition, like stressing why this is a problem, like why we have to solve this, why we cannot solve this. And then, after thinking about this, like really explaining the problem very well, like arguing for it, that it's a valid problem to solve, then saying that this can be solved with this technique, and maybe explaining how it can be solved. This is the challenging part, because this requires time. A proper presentation which explains how matrices, for example, can be used to represent graphs is actually, it's not that long, maybe half an hour, so this could fit in a video. But now if you want to connect it with Markov chains, that's another thing. If you want to connect it with graph search, that's another lecture. If you want to connect it with those oscillators, that's another lecture, which is connecting this to a totally different branch of mathematics now. I'm not sure whether this works or whether this leaves people even more confused, because it appears as if it explains how to do this without actually explaining how to do this. I guess that would be excusable if there was a link to a proper explanation.
This is what we call a not a strongly connected graph in tool, in fact. So the bottom one's a good example of this. Like, for instance, we'll say the nodes on the left do get to the nodes on the right, but the nodes on the right can never get back to the nodes on the left. In fact, there's that just big long arrow. Does not want to go backwards. You're stuck. Now you may ask, why am I bringing this up? Why is this useful? Well, it is. So it's something about, so if you have a strong connected graph, the matrix that represents that graph is what we call irreducible, right? And this means that all matrices that have non-negative parameters, weights in them, by the way, most of this I'm talking about is non-negative weights, but it doesn't matter, are reducible. So I've made it to make it simple. I've said all the weights are just 1 in this particular case, just to make it easier. But in general, this is what is going on. And this is just to show you.
Okay, this is something I didn't know. So the way I expected this to go is for him to actually do multiplication and repeat the multiplication a couple of times, squaring the matrix by itself, multiplying the matrix by itself, and squaring it. And then the matrix should fill with non-zero values. If there are some values, some zeros remaining in the matrix, then it means that it's actually separate components. But anyway, the proper way to detect whether you are dealing with a single component is not matrix approach, it's an algorithm called union find. It's much faster. It's a linear algorithm, essentially. You just scan through every node, scan through every edge, and you get the answer at the end.
Okay, this is
You even get the number of components out of this
matrix, and this is effectively the irreducible, the simplest form we can represent this graph in. Right? That's effectively what this means. You go, okay. But what if the matrix is reducible? Like, it means, okay, that means you can split them apart, make it into something else. You can go like, oh, look at this graph here. One side, one part of it is strongly connected. All those nodes can connect to each other. And the other part of the graph is also strongly connected. And then there's this weakly connecting edge connecting these two subgraphs, these strongly connected components together. So when you're thinking about it, you could actually describe both of these matrices. You can reduce them into irreducible graphs or irreducible matrices. That's kind of the point. So now
But seriously, if you ever need the strongly connected components, do not use matrices for that.
you can start.
It's just insanely more memory inefficient. Like, to represent a matrix, a connection matrix, you need n-squared memory. And for union find, it's linear. And the time is also linear for union find.
Thinking them in isolation. So when you look at this giant matrix, I've numbered them here, so 1, 2, 3, 4, 5, and 6, you can represent it with this matrix. Now it's just full of ones and zeros, but it's still not easy to explain unless someone's noticing a pattern. There is a pattern to this madness, right? It's because it's matrices within matrices, man. Let's refresh that. There we go. Technology. I love web browsers and their consistent rendering. But as you can note here, is that this top left-hand corner, the orange one, is the components within that the edges within that first component. The blue one is the edges within the second component. The bottom left-hand one is showing that one edge. There's only a single one in there, which represents going from the edges from the first component to the second component. And then finally, is the top right, which is a bunch of zeros, because you can't go back to the first. So effectively, you've now got a bunch of zeros, which you can just ignore, right? That's something that helps you do your algorithms. And you go, okay, well, again, why is this useful? Well, before we go there, again, if
Just
you
start
ask the
with
question,
that.
why is it useful? Why is it useful? Again, it's missing the point. This is tools in your toolbox. You don't know when you're going to know the use, but you might do, and you'll see why. So we've just rearranged this into this form. So we now have got effectively a bunch of matrices, but the top right-hand corner is just zeros, right? This has got a technical term. It's called, I'm going to probably get rid of this name wrong. I'm sorry. It's the Frobenius, I'm sorry, I can't do Prussian names. I apologize. He's dead, so I don't think he's going to be offended. But there's this Prussian mathematician, and he was kind of in this normal form. He's got a Frobenius normal form. Some people, you may hear it in some textbooks called as the irrational canonical form, or whatever. Effectively, is what you've got is a giant matrix where literally half of it is just a bunch of zeros, and then the rest of it is representing all of the irreducible submatrices or the subgraphs, those strongly connected things. And that's kind of how you're showing it. So you actually can demonstrate this all of here and go, oh, split it into smaller things and smaller or strongly connected graphs. So then you can also analyze them together or on their own. So you can actually see a bigger picture of nothing. One of the reasons why you're doing this is that you're not trying to, sometimes it's correction, but sometimes it's just not overfitting too much when you're trying to analyze these graphs. And it's very useful, but I'm going to stop, right? And there's a reason why I'm about to stop, because once you've got to this point here, right, that's understanding you can represent the graphic matrices, split them down to smaller matrices and smaller big graphs and rearrange them and all this, we can actually go into different parts and discuss completely different things. So I just started showing you there was a relationship between matrices and graphs. Okay, great. So what would this beginning of this talk actually been? Well, it could have been welcome to game AI, which I was kind of briefly talking about with all of these Markov chains and such, right? That's one place we could have started and then talked about all that for a while. Another one is welcome to machine learning. Seriously, this is actually beginning step when we learn about machine learning, because that in this form is great. That's really useful, so you do not effectively overmap on your model.
Yeah, a lot of those techniques are the same between game development and machine learning.
You can ignore completely, but these things are the important part. And also we know the relationships between these parts. And maybe you can do shortcuts, just cut things out, or
there's this whole idea
patterns of what are going on with the machine learning.
I mean, mathematics is
really
universal, right?
Or it could be something else.
Not much to say about this.
Welcome to traffic analysis. This is how traffic analysis, because again, these nodes could be traffic lights, the cars moving through them, the rates that they're doing. Like, this is actually what a lot of civil engineers are doing. Well done, you've now done civil engineering, but I could have started from there. It could have been, welcome to mesh topology. You go, wait, what? Yeah, so when you're representing meshes in games and such.
Actually, I think I could improve this API a little bit more, but I will have to restart from scratch. So instead of passing those smart pointers, when I'm constructing an object, I know that its parent is live. I can just pass a reference and the acquire pointer within the... Yeah.
Or not games, just like any 3D software, they're represented as nodes and edges. That you may hear things like half-edge meshes out there, or you may have this is the one I'm thinking of, radial edge meshes as well, right? So you have all these vertices, you'll have these edges, you'll have loops, you'll have faces. These are half-edge loops are, and you have all these different things that go together, but they're all just different types of nodes with different edges connecting all their relationships together. And then you may want to do analysis on this, see if you can actually break apart meshes, see where they're strongly connected and weakly connected, wherever, and then just do the stuff. Well done. You've now just done some mesh topology. But that's the whole point, right? This is the point. If you know your tools, you can then go and go, oh, I can learn these new fields, or actually I'm working in this field, this is actually really useful for me, right? Look, and this is the thing, is once you start learning more and more mathematics, there's an endless number of fields that you can apply this in programming to. And this is why I stopped in a very weird middle place, because I'm like, look, we could have gone to so many different areas. We could have gone to geometry, right? That was effectively done algebraic graph theory or algebraic geometry. We could have gone to traffic analysis, get machine learning, AI, whatever you wanted to do. But that's where we're getting to. And this is why it's so useful for people to know mathematics, because you don't know what you're doing, right? If you don't know it exists, you don't even know you could do it. But this is the beauty of it. Like, this is the beauty of learning mathematics in general, because it opens up so many different things for you that you didn't even imagine. And that's kind of where we've got to, right? Like, I've covered so many different topics. Like, I've talked about looking about instancias of educated guesses, differential equations, integrations, Taylor series, fixed time steps, numerical integrators.
And this is what
so many other things.
this is what I don't like about those videos, because they try to squeeze way too much. They don't explain it. They don't explain it from start. They assume that you know something, which you often don't. They miss important steps, and like this is what makes the YouTube different from attending lectures at a university. At university, you will have everything explained from the basics. You can come there not knowing anything, or like Khan Academy. Khan Academy also does this very well. It starts from a reasonable level, and it gives you all the basics and explains stuff slowly with pictures. And with those videos, you get an animation showing a method, but it only makes sense if you already know how it works. If you're trying to learn from it, it's just going to confuse you even more. So visiting the topics in this superficial way, I guess the point here is to refer the viewers to other materials here. I hope.
This is just the first half. And the second half was like matrices, directed graphs, weighted graphs, Markov chains, eigenvalues, eigenvectors, matrices, irreducibility, Frobenius form, it's text special Jacobian form as well. But the more you know, the more you can apply it to, and the more you're able to do. That is fundamentally, I want to try and get across in this entire thing. Learn some mathematics, you'll be a better programmer for it, and you will improve.
Okay, the important thing is, he says learn mathematics. You should give the sources, like materials. Because the internet is full of bullshit, and short videos which have nice animations rarely actually explain stuff.
So, thank you for listening to this talk with me. From me, Bill Hall, or Ginger Bill as most know. You can contact me on Twitter, also known as X, at thegingerbill, or go to my website, gingerbill.org, or my email, which is bill@gingerbill.org. You can view these slides on my website at bsc2025.gingerbill.org. So if you have any questions, please contact me. And again, thank you very much, everyone, at the Better Software Conference 2025. And thank you for this talk. Thank you very much, and goodbye.
Okay, so Bill, I thought it'd be funnier if you have to sort of pick questions from people yourself, because you know it's like, oh, that guy, he's a bank there.
Yeah, that guy there, please. Right there, please. No, yeah. Squinting, trying to get seats, like those.
So who do you want?
I'll take the guy with his hand. And,
yeah, Taylor, what's your question?
I can try and yell really loud. Can you hear me?
Just, yes.
So one of the things I find hard about mathematics is a lot of the concepts are named after mathematicians in the past, so various names, various...
Yes, eponyms. Those are terrible practice. All sorts of science fields are trying to avoid eponyms as much as possible because they make it unnecessarily complex for people to understand. For example, Dijkstra algorithm. You shouldn't say Dijkstra algorithm, you should say shortest path algorithm. I cannot actually think of others. Like Euler's algorithm, you should say GCD instead.
Country names, or from various dialects and whatnot, right? So they're often very hard to remember. As opposed to computer science, the names are often coming from regular linguistic words, right? Do you think that is, I guess, something that is just you have to get around, you have to get used to learning people's names and how to pronounce them, or could it be useful to rename these things with more like simple language, I guess, or something like that?
It's even worse in medicine. In medicine, almost everything is connected to a name of somebody who worked on it. But people are realizing that this is actually a problem, and it's actually making, everything unnecessarily hard for everybody.
Oh, good question. The thing is, computer science, a lot of things are still named after people, like Dijkstra's method. Many algorithms are named after people.
For shortest path algorithm.
However, in most fields, things are named after the people that discovered them. Computer science is just the weird one.
It's not entirely true. So in mathematics, or like in computer science and in many places, things are discovered but not invented. And when those things existed and could have been discovered by anyone, unlike inventions, which are usually done by a specific person. So attaching a name to a general concept, for instance, a Pythagorean theorem, it has been actually known way before Pythagoras lived. It's just the way we use it is because of the sources. The sources that we currently use, they came, if you track them back, they came from Pythagoras. But the theory itself, the formula for computing the hypothalamus, I don't remember the English name for this, existed long before that.
So I know it's sometimes hard to always remember the names, and I struggle as well. And as I said in there, the Frobenius form has got the rational canonical form is another name for it as well.
Yeah,
but,
he should have
it's
used the
still not
latter.
Simple language. Mathematicians are some of the worst people for naming things, even worse than programmers.
Actually, in mathematics, I very rarely see this. In mathematics, I very rarely see those unnecessary names. I actually would say that mathematicians are one of the probably the best people when coming up with names. Different branches of calculus, they have very well chosen names. Descriptive names, this is what it is.
They came from library in Alexandria, where Pythagoras was mentioned.
Yeah.
And the best way to get it around it is just don't remember the names, just remember the pattern, and then try and work backwards. But if you want to learn the names, usually sometimes the way I've always done it is learn the story for that person about how they discovered it and such like that.
Yeah, quite often when you have books, in mathematics, you have very cool books. Probably, so every kind of book on mathematics focuses on one technique, not every book in mathematics focuses on one technique, but it's a common pattern that a book touches a specific technique, or an article which lists all of the properties, for example, of those Frobius matrices, this is the first time I'm hearing about them, but I bet there is a compilation of techniques, there is an article or a monography that somebody compiled, which contains just everything that you can do with those matrices and all of their properties. And it's probably also the best place to... those kind of books are probably also the best place to actually learn those things. Once you learn this book, once you read a book like that, the name tends to stick in your memory better. So if you find a compilation of techniques for a specific type of matrices, you read through it, it's like one evening or a couple of evenings. You tend to remember this for life. So it's a good way to remember stuff.
Same with when it came to physics. I can remember some of the famous physicists by their names because of a story. Like, for instance, I don't know if it's Kepler or Tycho Brahe or Newton or Maxwell or something like that. I remember the stories of their life and then kind of know what it is. So it's kind of more of a historical biography for me than...
That's funny. I have no idea about their biographies.
The actual physics. I know that sounds weird, but that's the way I can...
But maybe this is the reason why people use them, because they, instead of learning the theory, they learn the biography of the person who invented something. And then it becomes more appealing, I guess, to call, because I guess they become more intimate with that person whom they learned about.
I'll take the guy on the left with the hand up. I don't know which one. I'm going to point to him.
Oh, John. So you don't want the doctor? There's a doctor on the right.
I know there's a doctor in the crowd. I was just picking random.
John.
So thank you for the talk. I love these like high-level overviews because they help you navigate. My problem, I mean, I have a great appreciation for math, but I'm not great at it, right? And it's hard for me to penetrate.
Yeah, this is because those overviews, they are terrible for learning stuff. Yes, lecture or anything. MIT has a great series. Like MIT is publishing a lot of their lectures. Khan Academy is amazing. I mean, it was amazing when I was looking at it many years ago. I looked at it a couple of months ago. The website was hard to navigate, and it was I felt it was less. It had less content, but still, Khan Academy. I guess if you can dig through the website, it's probably still nice. All sorts of university lectures that you can watch on YouTube are probably excellent, and they are definitely better than short videos which try to present a technique without its background.
Math concept, but usually I find them so convoluted. But when you give me these pieces like, oh look, this is this, and this is that, and that is that, it helps me immensely to penetrate the content because I know stuff, but I can't connect it. Like, do you have any like good resources? Like, cause
Exactly.
I
Yes.
read about math,
Online
I
videos are
draw,
terrible.
right?
Terrible.
But like, what's your resources, right? Or does it get better, right?
Oh, okay, you're going to hate this. I never can recommend resources to people. I agree with Wikipedia. So Wikipedia is usually the worst resource.
Wikipedia is bad. Wikipedia doesn't have explanations. It has definitions. So if you want to verify whether the thing you are dealing matches, the definition, Wikipedia is good for that. But if you want to understand the concept, Wikipedia has another page, it's called Wikibooks. Wikibooks is focused on explaining stuff, so Wikibooks is probably better for this.
Never can recommend resources to people. I agree with Wikipedia. So Wikipedia is usually the worst resource to learn anything from because it's not meant to be, right?
It's very formal.
Wikipedia is written for people who've already got a PhD in that topic and just want a refresher on it. That is pretty much what Wikipedia is written as, and it is great for those types of people. It is awful to actually learn from. For many of these topics, it's hard to find out where the best resources are. So for stuff like the linear algebra, stuff like that, I would recommend getting a book on physics, physics and engineers book. Like one of the good mathematics books I had when I was doing my degrees was literally mathematics.
Actually, this could be good advice. I was thinking on mathematics books, but the problem with mathematics books is that they try very hard to avoid pictures and diagrams. And physics books may actually be very good at this because they want to explain to you linear algebra just so that they can move on and use it to do stuff. So they try to explain it very well. But any sort of handbooks that people buy in academia are good. Handbooks, academic handbooks.
Engineers. It was a great book. It was very practical. It was literally like a doorstop, about 3 inches thick. But it went through all the different concepts and it just showed you all of them and gave you a load of examples to work through. As you get into other concepts, for instance, maybe let's say the graph theory stuff. Interestingly, on the graph theory stuff, some of that you may actually try different areas of mathematics. So this will sound very weird.
For graph theory, it's hard to recommend something. For algorithms in general, there is Cormen. It's a Bible. It contains everything. Cormen doesn't cover everything, but when it doesn't cover something, it usually has references to those things. And I think there are some probably maybe nicer explanations for some categories, like graphs, for example. Cormen is decent. But again, it has some diagrams, but not too much, not to explain it too well. I guess it's good enough. There are probably better books if you just search online on Amazon graphs. Probably people wrote some better compilations.
Makes sense in a minute. when you're doing graph theory, you can try and do it as abstractly as possible, and you learn about colorings of graphs and all this lot. Or you can go into, again, gambling. And then this will sound bizarre. I don't even enjoy it, but what I mean is a lot of games like this, and gambling games like this, are actually, this is how they do it. They're cheating. They're trying to find out where the distributions are so they can always have an advantage. So sometimes learning a field that uses it.
That's
and
interesting. I guess this is why he shown those matrices and balancing games. There is also a branch of mathematics called game theory, where you use matrices to express strategies sometimes, and there are some algorithms that can run on top of those matrices. But this is also something I used to teach at the university. I was teaching game theory there. However, I don't know which books explain it well. We used our own teaching materials there.
Finding it. So I can't really give you any specific resources because unfortunately, as you guessed by that talk, it was a tangent followed by a tangent followed by a tangent, and it was all over the place. That's how my mind works in general. So I'm probably the worst person to give you a resource for. So I'm sorry about that. But literally, pick a topic, find the areas in that field, all the books on it, and then just keep doing that, and you'll eventually get this scatterbrain like myself.
Thank you.
Can we do the doctor now? The surgeon?
Well, I basically had
Hello.
more or less. Hi, Bill. More or less, I had the same question actually. Like, yes, I was inspired by this talk, and now I want to learn about math.
Yeah. I really agree with the objective of this talk, which is to inspire. The best way to do this. It would be good if he gave some actually references to follow on for any of those branches, for instance. We have so many issues here.
First and only resource is Wikipedia, because the other resource would be to actually apply for a university degree and then do the courses. Because I can't find anything in between.
You don't have to apply for university degree. You can just follow courses yourself. There are online. They are often published online. Many universities do this.
Of how to solve that, besides, well, like I said, practical problems. But that's how people do it, by learning. I learn it on the way, because that's, I think, the only way I know of learning about those mathematical concepts.
And you already went to school to become a surgeon, right? So.
No, but yeah, again, I think the point here is when I say learn a random topic, I mean literally learn something. Like, for instance, I taught myself a game theory course. So I was at university course and took a game theory course, even though it was not related to what I was doing. And from that, I learned linear programming, which is constraint solving. And you think, why would that have anything to do with game theory? And the answer is, it's actually just constraints at the end of the day. You have most games, basic like the non-zero-sum games.
It depends.
They're all just a bunch of constraints. You put them into a giant matrix, and then you solve it with a simplex method. Simplex method is a way to solve linear systems usually.
Yeah.
And it's like, okay, I really when I learned this, I went, oh my goodness, this is now I could have used this anywhere in programming, but I just didn't know it. But that's kind of the thing is, when I say learn as much as you can, literally learn as much as you can everywhere you can. Try and be a polymath, a Renaissance man. I don't know whatever you want to call it, but I'm not. I know that's. You'll be surprised what you'll find, is what I'm trying to say.
So this advice is unnecessarily chaotic. You can, you're not going to learn everything, but it's good to have some areas of interest. And in those areas, you can usually find a single resource that you will follow. Usually, when the topic is being taught, it's being taught in a specific order with some prerequisites at the start. So you need to go. So jumping in the middle or watching random materials often can be confusing, and this is the experience that you may get if you're trying to learn something online. Once you stick to a single source and try to follow it through, it's way easier. It's way more organized than.
And this again, I can't tell you how.
Things make more sense.
Read this book, because that's not even how I learned. And I know we also talk about university courses. You'll be surprised. Most universities, or not most, a lot of universities will tell you what books they are recommending and what courses are. The thing you're paying for at the end of the day is that piece of paper. Also, many universities, if they're open campuses, you can just walk in and audit them. Like, seriously, you can just do that. I used to do that for courses at university. I used to go on music classes. I did a physics degree, I wasn't doing music. But I used to walk in and just audit them. And the thing is, and again, this is a fun fact, most lecturers and professors don't care. You just sit in them. You're not taking the exam at the end.
That's true. That's crazy advice, but it's true. You can. So I think you will be kicked out. I think you will be kicked out, especially on the later years when people know each other. But on the earlier years, you can probably come to the auditorium and just sit there.
Maybe, I don't know if that's technically bad advice I'm giving you, but it should work. Right.
Bill?
Anyone else with the questions?
There is one.
Oh, okay. Yes, I can see.
Sorry.
Do you have any opinion on geometric algebra for game development?
Just don't bother. I went down the rabbit hole of just generalized abstract algebra in general. So GR algebra and like Clifford algebras and all that stuff in general years ago. And my eventual answer to this was, it's not that useful. It's just another way of thinking about things. But if you're thinking about, oh, this would be really useful because you now unify the entire algebra, this Clifford algebra, which is what, 3 spatial, 1 time, and then all the other stuff on top. It doesn't actually make it harder. You just now got loads more different operators to worry about. And when you actually deal like with physics, they still keep the basic vector calculus stuff that you're doing everywhere. And then they do it very piecemeal wise, because in general, those are the operations you're doing. Now, if you do the geometric stuff, yes, it looks more elegant, but the mathematics that you're going to do at the end of the day will be the same thing. It's the same computation. All it does is it may look more fancier to you and then make it completely obtuse to everyone else on your team who can't read it. So it is the balancing act of, are you doing this because it's actually going to be useful for you, or are you doing this because you think it's cool? Remember, you're not a programmer, so this is not cool. Right.
Oh, we
Yes.
got many questions now. Andrew?
Maybe a silly question, so on more specific topics. With the love example,
Yes.
we started with a difference from time equals 0, and then changed that into an incremental algorithm. And it seems to be that the incremental part of that was what caused the error to accumulate.
Correct.
How do you feel about, like, do you have any general thoughts on the kind of incremental algorithm versus trying to do the total solve from a particular point in time?
You mean like a
So just making t equals 0 from the time when the animation started, rather than accumulating each.
If you can do it, then do it. If you can do the actual calculation, like you know the exact time it's working from, then do it that way. The thing is, a lot of stuff, if you're doing like physics simulation, for example, again, the talk previously was doing that in many cases, they're integrators. You don't necessarily know what's going to happen, but you know, like we say, the differential equation, that you know how the state evolves as it goes times up. You just don't know the full state of the system. Sometimes you have to do an integrator. You have to integrate, literally add every single equation. But if you have the beauty, the luxury to have this, we know we can actually just put a time in, do that. This example I did was literally because I remember on the Molly Rockets forums about over 2 years ago, I was speaking to Ryan, and Ryan was doing it. I just derived it and I went, here you go, here's the frame rate independent form of it. And it's just one of those, but sometimes that's what you've got to do. And again, physics simulations, anything that's differential equations. Pretty much most of the world can be derived from differential equations. That's what a physicist will tell you, obviously, but it's kind of true. And most of the time, you cannot know the whole state. You can only know the local changes in that state, and that's pretty much how the universe works anyway. Like you can only know the local space and literally how that evolves. You can't just know the giant equation, everything. Not even God knows that. So that's a better way of putting it.
John, you had another question? Unless Taylor wants to go first.
Yeah. So So you swapped between like notation you might see in a programming language over to mathematics and then back to a programming language.
Yes.
Do you think there's room for getting our, like, whether it's text editor or various tooling to have like typesetting for mathematics inside the programming language, or at least in comments or side text or something like that?
There are text plugins that already do this, especially for like LaTeX, I remember it's already doing that. So they usually do it just in the comments. So if you make sure you do like the dollar sign, then it will do it within them. But so that's already a plugin thing, and it's quite useful if you want to actually explain it. But I don't think it should be within the actual code itself. This will sound weird, but especially if we're I was showing it imperative procedural code, obviously. I don't think that should be trying to be blended into mathematics and use all the fancy symbols, even if you could, just because how you're conceptualizing that is very different to how most of the things work. So you can't, for me at least, I like that distinction between the things. So I can have like a context switch, change the hat that I'm working on for the different things. But yes, it is sometimes nicer to blend it, but it's a different trade-offs. This becomes a language at that point, and then it's like, imperative procedural program has been solved since the 60s, and there's not much that's going to change now, unless you create a complete new paradigm, which I doubt is going to happen anytime soon.
Follow-up question: would you rather the variable names be named after the mathematical terms rather than like whatever makes sense in a programming sense?
No, so this is actually a thing I absolutely hate about mathematicians who become programmers, is when they literally just do the BA, that's literally one character symbols. And this is a lot of times why people hate shadowing so much in languages, say imperative languages.
It depends. Sometimes it's acceptable. Like for simple things,
like
right?
DT is very common convention, say actually delta time. But please, I'd rather have a literal paragraph than you just use some arcane like, oh, this is Z. Like, what does Z mean? Well, Z is actually the decay constant for the blah blah. But it's like, just write the decay constant for the blah blah, please. Just write that out. You've got fingers, you can type it. You're not. This is the thing that people forget, is that mathematicians like short things because they're manipulating symbols on paper a lot of the time. You're programmers. You've got your 10 digits, you're typing on a keyboard, you can manipulate it. You're not manipulating it like that. It's a very different way of thinking and different domain entirely. So just type things out, you're reading, it's not manipulation.
Okay, we have time for one final question before we go on break. Somebody have the one final question to end all questions. Vladimir.
There we go. Guy at the top.
Does the mathematical universe map well to the actual computer? For example, in the LERP example you gave, right, you're integrating over real numbers, you're using all these theorems, and so you're sacrificing some amount of rigor when you go and translate that into appropriate code. So, is that just in general not a problem? Like you can just...
Oh no, it is a problem. So first off, rigor, you're talking to a physicist, I'll bodge anything usually. But it's... The thing about it is, it's very important to know real numbers, right? Reals and floats, they've always got things to have to take into account. And you have to know what the precision on those floats are when you're dealing with them. So when you're doing, like, again, we do fluid simulations as well, right? A lot of the time we're trying to just keep them into 16-bit floats everywhere on the CPU. We're doing this because we want to minimize bandwidth and also maximize the amount of VRAM we're trying to use with GPU RAM. The problem is, we can also get it works faster with less precision. So you have to also worry about, okay, so how do you have to do the operations to minimize those errors as well? So you've got all of these things on top. So you see, it doesn't map to the real world. It's like, well, floats are their own weird thing that you have to consider and understand how they work. So you have to kind of have this own mental model of how they operate. And again, in a mathematical sense, they're not rigorous, right? Because they've got things in them called numbers. They're not a number. So they're not reals in the first place. So it's kind of, you've got all this. If someone tried to mathematically describe floats, they'd struggle a lot, is what I'm trying to say. But you have to kind of think like, yeah, you've got this, not idealized thing, you've got this set of mathematics, then you're applying it to the real world, and then you can say, oh, there's actually these problems here. Like engineers have to do this, by the way, as well. It's not just programmers have this issue. Even if you don't have floating points, things are fudgy. At the end of the day, you're going to have errors in your measurements everywhere because every measurement you have has an error associated with it. You can't get around that. There's nothing perfect. So you always have to figure out what your tolerances are, what's acceptable, and just how to just know the constraints of your problem, fundamentally. Like, what is the tool that you use, the platform you're using, whatever it is. It doesn't have to be floats, it could just be integers, and the issues then will float fixed point in arithmetic or whatever on top. Hope that answers your question.
Okay, with that, so we're about to go on break, and then I want us to come back at 1:15 for Vyakoslav's talk. Can we get another round of applause for Bill?
Thank you very much.
Yeah, this was a nice talk. I may have been complaining, but I very much agree with the premise of the talk. It is something very valuable, very necessary to motivate people, because motivation is the key. If you have motivation, everything else seems easier. This I was commenting on many things, but those were mostly very subtle. I would even call them nitpicks. There is a whole kind of culture of online videos which superficially explain stuff. This is what annoys me, the fact that a lot of this explanation kind of followed this pattern. But I guess this is how it looks with popular science. Okay, we may actually watch the next one as well, because the change I'm doing right now is a very boring refactoring, so I can do this without thinking. You can watch another video in the meantime. File pilot, yeah. A truly impressive piece of software.
All right, awesome. This is my utmost pleasure to welcome to the stage the author of the tech that will blow the minds of every Linux and Mac user.
Although I will have to say that on Linux we have this stuff everywhere. It's fairly standard to have a good file manager on Linux. File managers do not on Linux. Software doesn't get entity-fied as much, so we don't have this problem. I guess if I check my size of Nemo, it's about the same size as this program. So yeah, it's just on Linux those things are kind of standard. They are kind of expected. So that's the difference. On Windows, it's kind of expected that the software is going to be garbage. So when you finally see a well-written piece of software, it's like truly impressive.
Oh,
but it doesn't take anything away from this app. It's very hard to do well-written software on Windows.
A graphical application for file exploring, searching, file pilot. Please welcome, round of applause for Vyakoslav Krajacic.
Thank you, Łukasz. So, hello, everyone. I'm gonna go and start with a joke because apparently we have a technical problem. A lot of people cannot pronounce my name here, and roughly 50% of people think that I'm from Russia. And apparently, Tweaking File Manager were popular there back in the day, but I'm actually from Croatia. So it's a small country on the Mediterranean.
A beautiful place.
It has extremely diverse landscape, from mountains and beautiful coastline to wheat fields, and it also has it has a long history dating back to 7th century. It's mostly Catholic country, at least on paper, though I try to live up to that. And yeah, you should definitely visit if you ever have a chance. So, what's my story? Why I'm here? I'm the creator of FilePilot. It's a file manager that's currently available for Windows only. It's in beta. And yeah, I started writing this roughly 3.5 years ago. And it was pretty much written from scratch. So the topic of today is going to be me trying to explain at least some parts of the code. And yeah, a background about me. So prior to working on FilePilot, I was actually a co-founder and I ran a game development company with my friends for more than a decade. The company was also based in Croatia, and we shipped games to millions of users, players, on Steam and on mobile, web, and even consoles. And my job there wasn't game design. It was mostly of technical nature. But one very useful thing for me was that I learned how to finish a project and how to push something to the end users or players. So yeah, even back there, back in my old company. So I left my old company in 2022 to start working on File Manager. But even prior to that, while I was in my company, we used to watch this one guy who was programming a game from scratch every night. And it had a really big impact on how we programmed in our company. Even though we actually didn't, we used commercial game engines to ship games, but it wasn't. So we.
This is the way to ship games, to use an engine. If you don't use an engine, you will end up writing an engine.
Programming, which was the topic of the today, and we started writing a more straightforward procedural code, and so it wasn't so uncommon for our projects to have like scripts spanning tens of thousands of lines of code instead of small scripts. I think that we pretty much broke every Unity recommendation ever had. And people coming to our company usually were a bit confused because we wrote software in a really unconventional way for Unity games. So at that time, I had a toy project I was working on in my free time. It was mostly serving as a playground for the things that I had learned from Handling Zero and other similar resources. It had only basic file navigation stuff. It was code-named Pleasure at the time. And at that point, I had also been a user of Total Commander for maybe 5 to 10 years. So I was already aware of the file managers, at least on Windows, the landscape of file managers, and many of those were definitive improvements over File Explorer, which isn't hard. But they were still showing age because a lot of them were written like in the 90s, so in early versions for early versions of Windows, and some even prior to that. So I saw a good opportunity for the business perspective. This is my prompt engineering skills in generating images. So I saw a good opportunity for writing a file manager from a business perspective because I thought that pretty much everyone who is using PCs for the work is using file manager to some extent. So yeah, it was a tough decision because I had 3 kids at the time, but I talked to my wife and she gave me her full support. We had some savings. I also got some money from my old company, so I decided to give it a go. But I couldn't help thinking myself, so what happens if I fail at this project? What happens if I spend all of our money? And there was this meme that was circulating quite a lot at that time, and it stuck with me. Anyway, fortunately for me, and for you, Casey, that didn't happen. I shipped File Pilot early this year, and reactions were really good. It even took me by surprise. So I want to try to explain why do I think that people reacted this way, and why do I think that it corresponds with some of the design goals I had for File Pilot right from the beginning. So probably the first thing that stands out when you download a File Pilot is that it's only a 2 megabyte file. And this is something that a lot of people cannot comprehend today. We are pretty much, people obviously don't know that we used to ship software like this. This even, sometimes this even hurt because a lot of people complain that Windows is complaining that this is a virus. And I did sign the executable, and it's probably the worst money spent ever. Because obviously it doesn't help. So the next thing...
This is actually interesting. I was looking into certificates. So why does it still complain it's a virus?
It's a standalone executable, meaning that you don't have to install anything, which is also something that people are not accustomed to today. So usually you will stare at these installer screens for minutes as it scatters junks on your PC, like background services and registry entries and who knows what. File Pilot does have optional installer, but it's so simple, it's embedded into the executable, and all it does is it copies the executable wherever you want, and it has a couple of options. I was so lazy with that, I didn't even multi-thread the code that copies the file. Like, it's so small that like it doesn't matter. So yeah, it's completely optional. The program works without it, and I know that a lot of people really appreciate that. So the next is startup time. File Pilot is launching pretty fast, at least for today's standard. This is a picture of a profiler. I apologize for the tiny text. But I wanted to show that most of the time spent booting File Pilot is actually OpenGL initializing its context and Windows showing its window. So the horizontal axis is time in milliseconds, and the vertical axis is number of threads. So the way I mitigated this is I tried to preload as much stuff as I can while OpenGL is doing its stuff. So I will usually preload fonts and icons and files and stuff like that. So by the time that Windows is done and ready to display the window, I will have pretty much everything I need to display it to the user. Next is speed. This is probably the most important one, and it's the one that a lot of people are really happy about.
Actually, this is interesting. So preloading can start like one of the first things we do when starting the app. Even before initializing anything, we can start preloading textures. I mean preloading. They are within Automat, the textures are encoded as WebP files. So this could be shifted in time a little bit earlier.
File Pilot can index millions of files in seconds on modern hardware. And it's weird because I'm actually using very old Win APIs from the 90s to do that. So this is pretty much on the hardware, not on the me. But in the future, I plan to support directly reading master file table from the disk. So these operations will probably take like it will be instant for pretty much anything. But it's not only the raw indexing speed, it's the responsiveness of the whole UI, which a lot of users is really liking. Then there's the UI. This is something that was very important to me right from the start, because I think that most screen real estate should be used to display files and file contents, and not the actual UI. File Pilot, a prime example of that would be command palette. So a command palette is not visible by default, but it can easily be summoned by a simple hotkey, and you can filter pretty much everything you can do with File Pilot. You can also rebind hotkeys here. also the fact that I'm using this as a showcasing program on stage is kind of proves my point. The UI is real simple. And finally, there's personalization or configuration. And this one is probably the toughest one for me because I think that each program should pretty much.
This is a big open problem in actually programming. You have a program that you want to alter a little bit, and for each alteration, the programmer of the original program has to inject some mechanism for you to change it. It could be settings, extension mechanism, theming, whatever. It's very hard to personalize, to customize software once it's written and packaged.
Much work like it is from the start. Users should not configure anything. Too much options usually show there's some leakage in the core design. And FilePilot is trying to be very modest here. So I offered a very couple of options here, mostly related to files, and you can change the color theme and stuff like that. A lot of people on our Discord servers will often ask me for new features, and when I tell them you can do that in some other ways inside FilePilot, they will usually tell me, okay, but can you add an option for that at least? So it doesn't have to be on by default, but adding options in that manner quickly becomes nightmare. You don't want to add option for every tiny thing. So it's really hard keeping this simple. FilePilot is currently in free beta, but there's options.
Yeah, this is something that I would like to tackle in Automat, this customization, this open-endedness of almost everything. And it's something that I think we can tackle using object-oriented techniques. A program which is written and ready and it exists, it's not an atomic, it's not a black box entirely. It can be analyzed, it can be introspected. So I hope that by using proper objects, we should be able to edit files which were already built and also provide very nice interfaces for doing so. Like, for instance, to connect to another app which is running and dynamically modify its memory according to some whatever custom function. It should be possible.
Pre-orders and prices are a bit spicy, but I wanted them to reflect the engineering effort that went into working on this project.
Sorry, is this a file manager with licenses?
But I was actually kind of surprised because
this is optional, I guess, right?
FilePilot already earned enough money to repay all my debts and to sustain further development. And thanks. So this actually proved one important thing to me, and a lot of people have been telling me this, and that's that you can sell something very cheap.
I think I was a little bit early to praise FilePilot. So what typically happens with this software is that it really depends on the author. If the author has the restraint to develop this software ethically, then it can work. But if he doesn't, I've seen this happen with a couple pieces of software, like for CAD, for instance. I think FilePilot actually has a large enough group of users that it might not happen. But there is this point at which all of the users who could have used this software already bought the license. There is no way to expand this group anymore. And the software is developed by a team which needs to make money. So what do? Right? Do you fire people? Do we dissolve the company because the software is made and was sold? That rarely happens. What typically happens is that there is some new version, and new versions keep appearing after that. And I see the same business model here. So if you buy a license, you get 3 year of updates, and then they stop. I mean, the software should keep working, right? It will probably keep working. I hope it will still be downloadable after you buy it once. But it's something that's very suspicious to me. I learned to avoid this kind of stuff.
Or even give it away for free, but if it doesn't stand out, people will just not buy it. But if you make something really, really good, people will gladly give you even more money if it improves their lives. So yeah, I mean, the quality of the product obviously really matters. Okay, and just a couple of statistics. So from the start, Pilot was downloaded more than 100,000 times, and I actually don't know the exact number because I missed tracking maybe first week or two when it was at peak. So I had to estimate those downloads based on the later traffic. So this number is very conservative. I would believe it's much higher than this. I received hundreds of emails, and even to this day, I receive dozens of emails a day. And it was actually kind of bottleneck for me, for my work, and probably not a smart idea to leave an email. But yeah, it is what it is. My Discord community grew from couple hundreds to couple thousands in just a few months. Sorry, Casey, about this. I was on the front page of the Hacker News. And I got a lot of YouTube reviews, even by some notable people like Scott Hanselman. And I received fair amount of Twitter coverage, and it was all in very. I didn't pay for any ads. It was like mostly people sharing around.
Nice.
Okay, so Pilot was I would say it was quite a success, at least from my standpoint. And why do I think that is, and why do I think that writing it from scratch was a very important part of this whole process? And that is pretty much summarized in this one. I think that speed really matters, and I think that it matters now more than ever. And it's kind of weird because a lot of people are trying to tell us otherwise. A lot of people will tell you that speed is just another feature, which is kind of bizarre proposition. And
if the software doesn't do anything, the speed doesn't matter. Like, this is certainly true. So I think this is the advice that people give. So before optimizing, it's good to have something that can do stuff. So I wouldn't focus on speed from the get-go. It's good to keep it on the back of your head. It's not the most important thing, definitely.
They can be quite dogmatic about it. They will say things like, human hours are more important than CPU cycles. But when they say human hours, they are probably referring to themselves, to the developers. But my question is, what about the other side of the equation? What about the users who are using your software and spending their time? And I want to be a bit more concrete on this one. So these are just made up numbers, but just to give you a perception, imagine that you have 1 million users and that each one is issuing one search request a day. And let's be generous to File Explorer and say it takes 1 minute to return results. We're talking roughly about 58 years of accumulated users' time each day. And imagine now that this search results in 1 second. That's roughly 60 times faster. And this is just one day, just one search, and just one program. We are using a ton of software each day. So can you imagine across the board the inefficiency we are dealt with because our software is that slow?
Yeah, it's even worse than that because waiting is a context switch for the user. Like forces a context switch if it's too long. It makes it harder to learn how software works. So the estimate that he gave, 4 years, which is just a multiplication, probably actually way higher if you include the time needed to regain focus and so on.
And there's one other thing that I think that Ryan mentioned in the Twitter some time ago, and that is that speed is just the first order effect. And that means that it's great when something is really fast, but what speed gives you, actually, it opens opportunity for some new features that wouldn't have been possible if your program wasn't fast enough. So a good example of that in file managers and in other software too is search functionality. So a regular way for that would be you enter some search term in the search box and you wait on the results. And if those results are not what you want, you repeat the process. And what if you had instant access to the files, or if you had a close approximation of that? Well, in that scenario, why would you not just respond to each letter you type and just present the new files? And that's called filtering, and it's actually how FilePilot does it. So this wasn't my plan when I started doing this, but when I saw how fast I can index files, I just went with it. So FilePilot doesn't have traditional search functions. What it does have is a function to filter on files, and it has a function on flattening the folder hierarchies. So for instance, if you want to search across your whole drive, what you would do, you would go to the C drive and you would flatten the whole drive, and it would display all files on your drive in one listing. And then you can just apply filtering to that, and you pretty much have searching in real time. So yeah, I hope that a lot of people agree with me on this one. So this actually brings me to the topic of this day. How did I build FilePilot, and why was building from scratch such an important part of it? So this is the sketch of my project, broken down by modules. At the top we have a base layer, and this is where most core code lives, where all other modules depend on. Then we have a platform layer. This is, in my case, currently only Windows. And this layer it fetches files and thumbnails and everything I need for it. It also is respected for opening a Windows, closing Windows, getting input and stuff like that. Then there's a program layer, which is the biggest part of my project, and that part is basically it's organizing all pieces together, and the main goal of the program layer is to build UI for the user. And so when the user issues something like clicking on button, or it requests a new files, the program layer will dispatch every request to the platform layer, and it will rebuild the UI. Then there's the renderer, which is currently in my case it's OpenGL renderer, but I plan to move to DirectX on Windows. The renderer is really simple because FilePilot didn't have any special needs. It's only drawing colored quads. And then I have a UI framework that was built directly on top of it. And this is actually the part that a lot of people are asking me about, because it's the main thing that people recognize when they try FilePilot, the responsiveness of the UI. So the UI was written entirely from scratch also, and it used immediate mode kind of API for building it. And finally, I have a very small amount of tiny libraries that I will sometimes include. These are usually single-header libraries from people like us. And some people will be surprised by this, but pretty much every module corresponds to one big C file. Yeah, I know. I'm a big fan of big files. Splitting things into too many files actually doesn't help me in organizing.
That makes it more impressive, I think.
So
it's very hard to write complex software in C.
Is at around 100,000 lines of code, and here's the intersection per each module. So more than a half code is written in the program layer, and all other layers form other half.
Oh. Okay, I was feeling bad about 2,000 files
generated
in a single file.
So my currently my project rebuilds in debug mode in 2.5 seconds, and I can't emphasize enough how important this was for me and for my development iteration cycle, because I can pretty much do whatever I want and test those things immediately, and it makes a huge difference because it motivates you to experiment with new stuff. This is my build system, which is a small batch script, which invokes compiler with a couple of options, and that's pretty much it. And yeah, it's crazy how this is faster than incremental linking, which was also discussed today. This is something that's very specific to, it uses Unity build, and it's something that's very specific to C and C++ code bases. It essentially boils down to compiling everything into single translation unit. Speaking of code generation, I want to mention one thing briefly before I go into code snippets. This is something I started working right at the beginning of the project. So C is very old programming language at this point, and it has some really annoying restrictions on how you need to order your function declarations and structs. So for instance, if a function wants to call another function, that function has to go above it, and same is true for the struct. And so what usually people do is they split the structs and function declarations in a separate file. And so what I did here, I prepended all my functions with a made-up word. I didn't have to do that for struct because I already had that. And so each time I hit a rebuild of my project, I make a prepass that generates another file that has included all the type defs for structures